Hey. Good morning. Good morning. So, hopefully you all are here for the web application developer training. Is anybody here for something else? No? All right, cool. We're all in the right place. That's good. Me too. Real quick, I'm Josh. This is Dan. We're your instructors for today. We've been doing this training many years. I want to say 2014, 2015 is the first time we did this. And at this point, it's kind of second nature to us. If you guys have questions, this training is for you guys, right? If you have questions, raise your hand, speak up, whatever. There's a lot of PowerPoint here. When I do this training with my developer teams, I mix in the PowerPoint with actual hands-on activities. That training lasts 3-4 days. This training is 1 day. So we gotta squish it all, we gotta just do the PowerPoint stuff. But if we lose you guys, if you have questions, raise your hand, speak up. I don't understand that, right? Real quick in terms of attribution, so the slides in this presentation were originally created mostly by Denver. I then took some of these slides in my role at National Instruments, and I tweaked them for my organization. But since that point in time, the OWASP Top 10 has changed. Things are very different now. And so, while the stuff we're going to talk about is very much relevant still today, Denim Group has newer material, right? And so if you decide that you want to bring something like this into your organization, they've got much more current, much better stuff, right? This content is available online. Dan and I have licensed it under a Creative Commons license, which means that you guys can take this presentation and you can use it internally if you want. If you feel comfortable retraining your organization, or if a manager wants to download on what you learned, feel free to take these slides. And so I'm going to put this link up here. You guys will want to write this down. This link right here is the link to all of the slides. So you will be able to download these slides that I'm showing you today. You'll be able to download those. You'll be able to use them to train, to use them to review, whatever you need. So I'll give you a couple seconds here, take a picture. Anybody know a good joke in the meantime? Everybody preparing for Halloween? Yeah, all right, good deal. I was thinking about Halloween costumes, and I thought about dressing up as a UDP packet, but I didn't think anybody would get it. All right, cool, on to the next. So what we're going to talk about today, we're going to talk about principles in application, specifically different concepts, different tools that you can use for testing. Introduction, basic security principles, input validation is going to be a very kind of fundamental theme throughout this course. We'll talk about common vulnerabilities, OWASP Top 10. We'll talk about coding and design, so we'll look at some other vulnerabilities, some buffer overflows, denial of service, configuration management. We will talk about the SDLC, and if we have time, we may talk about elements of secure design, and maybe even we'll cover a little bit of threat modeling. Nowhere near the depth that the other classes can do, but we'll do some of that. So who am I? I'm Josh. I run the information security program at National Instruments. I've been running that team for 10 years. I've been working at NI for 13. I'm also the creator and CEO of a company called Simforce that does risk management software, free open source risk management. If you need to reach me, Josh.Sokol at OWASP. And then on Twitter, I'm at JoshSokol. That's you.
That's me. Hey, I'm going to check. I'm Dan Cornell. Now I'm the founder, one of the founders of the CTO at Denver. We do application security work, and we have our ThreadFix platform to run application security and vulnerability management programs. I'm a developer by background, originally in the mid to late 90s, a lot of Java, early server-side Java stuff, in the early 2000s doing some .NET stuff. Although for the last probably 15 years, my focus has been working with folks on the security of the software that they're developing. But by way of background, I'm a developer that has come into the world of security as opposed to someone with a network pen testing or something type background now looking at applications. And so I'm a developer, kind of spin on the way that I see a lot of things. I help to run the OWASP San Antonio chapter along with a couple other folks. And and I'm dan@denver.com or at Daniel Cornell, because whoever took at Dan Cornell never used their Twitter account. So I'm at Daniel.
Bastard.
Yeah, I know.
Yeah, it's funny. It's almost a blessing and a curse. So I have at Josh Sokol. I'm very fortunate. But there's another Josh Sokol out there who's like an astrophysicist. And I keep getting these tweets at me, like, Josh Sokol discovered blah, blah, blah. And I'm like, no, not me. In fact, just this morning, I had to tweet back. And I was like, there was a thing on Twitter that said, Josh Sokol, English major and likes reading. And it's like, I don't like reading, and I was a computer science major. So, not all is cracked up. All right, so let's get into it. Application security. There we go. Application security is basically ensuring that a custom application performs as expected under the entire range of possible inputs. And our goals are what they call CIA, confidentiality, integrity, and availability. And that little picture right there is the CIA triad, right? Everything kind of wraps around our data. There's a direct relationship to software quality assurance. So if you have a software QA organization, application security is really just a subset of SQA. SQA typically focuses on verifying that the software does what it's supposed to do. Right? Here's the list of all the features and functionality that I expect from this. And then application security is, does the software do something that it shouldn't? Right? And if we're good hackers, we're able to make it do all sorts of things. So in a perfect world, it looks something like this. The intended functionality and the actual functionality directly overlap. Right? It's perfect. How many of you guys write perfect software? We got one. Awesome. So the reality is that 99% of us aren't perfect. We have some flaws. And so in the real world, it looks something like this. You've got the intended functionality, you've got the actual functionality, and they don't quite overlap, right? Not perfectly. And so in the area where you have actual functionality that wasn't intended, this is unintended and undocumented functionality. This is our application security issues. In the middle, where we have actual and intended functionality overlapping, we have our built features. This is the stuff that we wanted to design, we actually did design, we're good. And then where we have intended functionality that wasn't actual functionality, those are our bugs, right? So, there are some cultural differences between application security, information security, and the development side of the house. In information security, we typically have a measure culture. What that means is that we're going to look at something, we're going to determine the controls that are in place, how the system runs, we're going to audit the configurations, make sure that they are configured as intended, and we're going to monitor the system while it's in operation to make sure that nothing's going wrong. In application development and systems integration, we typically have a build culture. And what I mean by that is that you are creating something that did not exist before. You are writing code from scratch. And you typically have some sort of a project-based deadline environment. So somebody says, hey, by this date we need to develop these features that don't exist today. And then by this date we need to add these features, right? So a little bit different in terms of culture. Why does application security matter to us? Well, a lot of us are developing business-critical web applications that face the internet. And we all know that the internet is a very scary place. There's people out there that want to do bad things. And every day we're seeing news articles and magazines and Twitter and whatever that are telling us about these exploits. That are telling us about companies that are being breached, applications that are being breached. And we have even more data that's available to trusted insiders. So I saw a cool picture the other day that was basically of an iceberg. And it was like, the top of the iceberg, the part that's above the water, is actually the smallest part of the iceberg, right? That's the internet. And then we have all the stuff that's underneath it. That's the internet. That's what every company out there has, right? So the exposure here is huge. The opportunity for an attacker to get at our data, to steal things, to take advantage of us is enormous. 96% of applications tested in 2013 had one or more serious security vulnerability. That's according to a Sensitive Vulnerability Report. I know that's an old metric, but all the data since then is basically pointing to the same thing. Applications, almost all applications, have web application vulnerabilities that can be taken advantage of. All the stuff that we're going to talk about today is still very, very common in web applications, and even me, with my application that I write to my developers, we still see vulnerabilities being built into the application that shouldn't be built, that they know better. But sometimes it's just, that's how our brains work. But the more educated we can get, the more we understand where these vulnerabilities come from and how to fix them, the better off we're going to be in the long run. There's also new laws and regulations that govern how data is stored and made available. And actually, since we made this deck initially, there's even more. So back then, it was things like HIPAA, which governs health data. That's the thing you have to sign off when you go into the doctor's office. There's Sarbanes-Oxley, which governs publicly traded companies. There's things like California SB 1386, which has to do with PII in the state of California. There's PCI, which has to do with credit card data. But now there's even more. Now there's things like GDPR, which sounds like a four-letter word, but GDPR really is governing data privacy in Europe. And even though it applies to Europe, most of our companies here in the US are doing business with European citizens, which means that GDPR actually applies to us as well. Now, in terms of types of vulnerabilities, there's basically two types of vulnerabilities. There's technical vulnerabilities. Technical vulnerabilities typically surface due to insecure programming languages. So it usually has to do with some form of poor input handling and poor input validation. Meaning, as our data is coming into the application, somebody is not checking that data and verifying that that data is appropriate, that it's properly typed, that it doesn't contain bad things, and then they're handing that off to the application to be interpreted, to be utilized, and that's going to cause our issues. The good news is that most of our scanning tools are actually really good at finding technical vulnerabilities because it's data in, data out kind of thing, and computers are great at that. Feed some data in, check the output, and you discover your vulnerabilities. And the other good news here is that it's usually pretty easy to fix. The remediation is just changing the code, right? We need to add a routine to do the input validation. We need to add a routine to do output encoding. And by doing these things, we basically fix it oftentimes in multiple different places if we pick the right location. The other type of vulnerabilities is a logic vulnerability. And a logic vulnerability surfaces due to insecure program logic. This is the people side of the problem. This is usually due to poor decisions about trust. And because these are logic things, not code things, most of our scanning tools are actually powerless to find these kind of vulnerabilities. The remediation for these is architecture and design changes. So I'll give you an example here. Back in the day, there was this woman who was on an online shopping site, and she decided that she was going to buy, let's say, a new purse. All right? And she goes to the site, she clicks the purse that she wants, and she goes to the checkout page, and she enters her credit card information, and she hits purchase. And while the thing is crunching, you see the thing spinning, she goes, oh crap, probably should have asked my husband first, right? And she closes the browser. All right, done deal, right? No issues. What happens? Purse shows up in the mail. Oh my God, what's gonna happen? First thing she does, she checks her credit card receipt. No, there's shoes, there's a new dress. No, the purse isn't on there, right? She's going, all right, what should I do with this information? What do you think she did? Yeah, she goes back on the thing, back on the site. She's like, well, I paid for the last one. Wonder if I can make this happen again, right? So now she goes for the shoes. Right? She's like, all right, cool, let's get some new shoes. Same thing, selects the item, goes to the checkout page, purchase, and then at that same point, she closes the browser. New shoes show up in the mail, right? Checks her credit card statement, hasn't been charged. Cool. So what comes next? She's got the purse, she's got the shoes. Yeah. Outfits, right? But eventually you start getting too much stuff, right? You're like, man, I've already got my shoes, my purse, my outfit, I'm good for the next year. Eventually you start going, well, maybe I should buy some other stuff that I can sell, right? Make some money off of this deal. So that's what she does. She starts buying TVs and DVD players and things like that, right? Same process, I go through the site, I select the item, I click pay, and when I get to the certain point, I close it, and this stuff starts showing up in the mail, which she starts turning around on eBay, right? Now, this woman actually got caught. And the reason why she got caught is because when the stuff started showing up, the mailman would basically show up with these boxes. And she would go, cool, thank you. She'd grab the box, slap a new label on it, hand it right back to the mailman. And eventually the mailman gets suspicious of this, turns her in, and they find out that all this stuff is going on. Now I use this as an example of logic vulnerabilities because that's exactly what's happened here. In our application, some process has broken, right? The application logic says, go ahead and check out, enter your credit card information, process credit card information, and then ship. What step are we missing between process credit card information and ship? Validation, right? Did we actually get the money? Were we paid for this item? And that's a logic flaw. The computer can't find that. We as humans have to know, all right, when it gets to this point, we need to validate that we received payment before we ship item, right? So, OWASP Top 10. OWASP Top 10 is a great resource. The OWASP Top 10 has been around for many, many years. I think the first Top 10 was maybe 2007, 2006, 2007, something like that. It was recently updated. It was updated like last year, year before, something like that. This presentation is based on the 2013 list. And you can see the little plus and minus and renames. That's the difference between the 2013 list and I believe what was the 2017 list that came out, so you can kind of see how things shuffled around. But the reality is, most of the stuff on this list is the same. And that's because as developers, we have new developers graduating from schools. Those developers don't receive education on application security. We have old developers who are moving from one job to the next. They didn't get the education on application security. And as long as we're not educated, we're not understanding the issues that are out there, these issues are going to persist. So I thank you guys for coming to this presentation. I thank you guys for being here today because we're trying to change that. And that's the reason why we're doing this, this training at no cost, for free, is because we truly believe that you guys should have this education. You should have this background. I will note that this is not a complete list. The OWASP Top 10 is an awareness document for web application security, but there's not just 10 web application vulnerabilities. And it's not like when we check off cross-site scripting here. Everybody's good with cross-site scripting, right? Then the hackers are like, oh no, we can't do that anymore, right? So there's lots of other vulnerabilities out there, but these represent a broad consensus in terms of the most critical web application security flaws. If you want a more complete list, there's the Web Application Security Consortium, or OWASP, and they have a really cool project called the Threat Classification Project. That Threat Classification Project kind of takes everything and it breaks it out into different classifications and different silos and things like that. Really, really cool. So if you want to learn about more stuff, that's a great resource. And we'll be talking through the course of the day. I'll give you links and show you different other resources to look at for the different topics that we talk about. Any questions at this point? Hopefully I haven't lost anybody. We're going to move next into basic security principles and talk about some of those. So the goals for this section is to introduce you guys to general security principles and then relate them back to application security. And this will set the stage for future discussions, future materials, but all these concepts are critical. These are core to application security. The other stuff we're going to talk about is vulnerabilities and exploits and things like that. But most of the damage caused by those things is by not doing these things, right? So, let's talk about least privilege. Least privilege is the concept that will give a process only the authority it needs to do its job. So as an example, you might have a program that needs to log to a disk. And if you got your requirements from the business team for writing your application, it's like, hey, we need a log of things that happen in the application, right? That's pretty typical. Now, there's multiple different ways for me to interpret that requirement as a developer. The first is, I can give this raw disk access. It can write ones and zeros to the disk. The next is, I can give it read-write rights to a directory, right? So it can create files and things like that. I could give it read-write rights to a file, or I could just give it append rights. Can't delete, can't edit, it just adds to the end of the file. And the concept here is that the more finer-grained the security mechanism, as we go down from raw access to you can only write to the end of the file, the closer we're getting to least privilege and the more secure our design is. So we need to be thinking as we're going through, as we're architecting our application, does this app really need raw disk access? And 99% of the time, the answer is probably not, right? In terms of database access, the question we should be asking ourselves is what capabilities does a user's database connection have when performing an action? Should this application be using multiple database connections at the same time? Should the application ever need to drop a table or grant access to something, right? And if all this is an application that's maybe logging to a table, a transaction that happened, it only needs write access to that table, right? So our least privilege says, crunch that in, right? Set that privilege so that all it has is write access to that table. Now, at some point in time, it might need more access. We may make our application bigger, develop additional functionality, and that's okay. We can revise privileges, we can add new privileges, but the idea is that we start from a baseline of 0, or as close to 0 as we can get, and then we expand from there. Rather than just saying, well, 10 years from now, it might need read and write and execute and drop and create and whatever, so I'll just give it to it now, right? In terms of file access, the question we ask is what files can be read or written by the application or web server process? And what are those files used for? Are files able to be executed on the server? So for example, PHP, if I'm able to write a file to the server, that's a PHP file, that's PHP code in it, and I have a PHP interpreter, and that's in a web accessible directory, that means that I can now execute the contents of that file. So I can write whatever I want to it, create my own file, right? Which basically means that I can drop my own shell scripts onto there. I can drop my own PHP scripts. I can execute commands on the file system. So those are really, really dangerous things to have. What about encryption? Can we encrypt those files so that even if somebody gets that data, they can't actually access the data inside the file? In terms of user authentication routines, what are the different classes of users? What can each user do? Do we have different roles? Is there an administrative user? Is there a regular user, right? Questions about least privilege. All right, let's talk about defense in depth. Defense in depth says that we don't depend on a single security mechanism. Instead, what we do is we have multiple independent security measures in place, which means that if any one of those things fail, the whole system doesn't fail. It's actually a military term, right? So if we fail to employ defense in depth, we get these brittle security architectures where one issue brings down the whole stack. And we get a false sense of security. Yeah, we're protected, we got firewall. Yeah, that didn't work for Target, didn't work for Heartland, right? Firewall is one piece of the defense puzzle. We need to make sure that there are multiple pieces in place. If you do defense in depth, it could prevent the exploitability of vulnerabilities, or in some cases it may reduce the impact of the results of the vulnerability exploitation. So for example, you may have some vulnerability that allows somebody to download a file. Maybe it's like you have a publicly accessible S3 file. That's a big thing these days, right? And so if somebody can get that, and they get that data, like what happened with the state of Texas, if they're able to get that data, now they have access to social security numbers and names and addresses, right? But if we encrypted that file, and then put up as a form of defense in depth, now it doesn't matter if they actually were able to download that file, because then they still need the encryption key to be able to decrypt that file. So multiple layers of defense means that we're in a better place. And I use a picture of a castle here because I think castles are great examples of defense in depth. If all my castle was just a building in the middle of a field, it's not going to be very secure, right? Anybody's going to be able to come with their army and just crush me. So what do? I take my building that's surrounded by walls. All right, instantly a little bit safer, right? Because somebody has to figure out how do I go over, under, or through those walls, but I've made it more difficult for somebody to just kind of sneak in my door, right? Okay, well now I dig a moat around the outside of that wall. Now I've made it harder, right? Now I've filled that moat with alligators and sharks with laser beams, making it instantly harder, right? Now I put catapults on there, and I got boiling oil, and I've got archers, and right? The more things that I put in place, the more defense I have, the more defense in depth, the safer I am on the inside. That's what we're trying to do for application security. That's what we're trying to do for our applications. So extra security is typically good, but it generally means yet less usability. So if I'm the guy inside of that castle, and I have to go like push the archers out of the way, and like, hey dude, can you raise that boiling oil? I don't want it to spill on me, and lower the drawbridge or whatever. It's a lot harder for me to get out of that castle. But the castle is inherently more secure, right? And it's going to be a lot harder for me to get back into that castle, but again, it's more secure. So extra security, less usability, and there's frequently a trade-off. So here's an example. In this case, we have a company, they're called Acme Stuff. And Acme Stuff relies on firewall to block unauthorized access to their internal network. That firewall is the only layer of defense for this company. And this is very, very classic. There are many, many organizations where they're like, we got a firewall, good, secure, right? What happened? If that firewall is misconfigured, if there's an exploit that allows a valid service, a service that's actually poked through the firewall to be subverted, full access, right? And so if you look at your web apps, for example, our web applications are basically a hole poked through the firewall, 480, 443. So the attackers do have access through that firewall. We've intentionally opened that port. If there's a vulnerability in our web applications, that hole through the firewall just allowed them to exploit. So without defense in depth, we got problems. Now, if we take that and say, all right, let's not just the firewall. Now we've got multiple other protection mechanisms in place. So we're not just gonna rely on that thing. We're gonna put file permissions in place. We're gonna make sure that there's certain restrictions on there. And we're gonna have strong passwords, and we're gonna use account level restrictions, and we're gonna encrypt our data, and we're gonna do antivirus on our systems, right? Now what we've done is we've made it so that any of these attacks, if we have an attack that's attacking our web application, firewall gone, right? That was our first example. But now there's file permissions in the way. And that might stop some of the attackers. But maybe some of the attackers get hurt. Maybe they figure out another vulnerability, another way to do that. And oftentimes attackers are going to chain multiple different attacks together. So they figure out how to get past them. They get to strong passwords. We'll do that as a password cracking system with multiple GPUs, and you go boom, and now he's got the password, right? Or maybe he phishes somebody and steals the password, whatever. So now they get past that. Maybe somebody even gets past our account restrictions. They get the data, but our data was encrypted. Defense in depth is going to reduce the impact of any individual flaws because we're basically making it so that they have to go through each of these different layers to get the data. In terms of application security, this means choosing when to encrypt database data. It means implementing application-based authentication and authorization mechanisms. It means configuring our deployment environments, and it means installation guidance for IT departments, hardening processes. Questions about defense in depth? We're all on the same page. Yeah.
As a rule of thumb, what would you estimate the cost relative to, say, the application cost or applying debt, defensive debt?
So the question is, as a rule of thumb, what would the cost be to apply defense in depth to an application? And I don't have a good number for you because it's going to depend on the data that you're protecting. So if I'm protecting data that's a white paper about the product that my company sells, the number's probably zero, right? Or I just want to protect this asset so that nobody pops it. If it's, I'm the US military and I've got these top secret plans for a new stealth fighter jet, the answer is a lot, right? I should spend a lot of money to protect that, and I should put many, many layers in place. So it's going to depend on our data. And we as developers, we as business leaders, we have to evaluate the data that we're protecting. And we have to determine how much is this thing worth? How much is it worth to an attacker? How much is it worth to us? What's going to happen if this gets out? How do we keep this safe? Right? And it's entirely dependent on that data. All right, so let's talk fail-closed versus fail-open. Fail-closed systems will block access when they run into errors. You say, hey, problem, no more access. Right? Fail-open systems will allow access when they run into errors. And choosing which of these behaviors should be done explicitly and with care, because the result of that choice is going to determine what happens next, right? It has to be decided on a case-by-case basis. There is no right answer per se, but typically fail-closed is considered more secure because we're effectively saying if there's a failure, nothing else happens, right? We're stopping this transaction. All right, so pop quiz, fail-closed or fail-open. We got missile launch control software. Fail-closed, I hear a lot of fail-closed. Yeah, if that missile launches, we got big problems, right? We got more missiles coming in from Russia and all that other stuff. It would be bad, bad news, right? All right, you guys pass that. All right, how about fire door lock control software? Fail open because, yeah, if those doors are locked and we can't get out, it's a problem. People are gonna die. All right, credit card authorization routines. Business case, what do you mean?
It's be clear that maybe the service, the office for depending on the agreement for your customers.
Yeah.
What do you say?
So what he said is that it depends on what you're processing, what the thing is, and what your customers are expecting. So think about my example earlier, with the shoes and the dresses and the purses, right? Those are hard goods. And so if we fail open in that case, basically what we're saying is, hey, we probably have time to reattempt this transaction. We can say, all right, let me take this, I'll take the authorization, we'll prepare the order, but we're not going to actually ship it until we verify that transaction, right? So we can probably fail open in that case. If it's something like a soft good, like here's a PDF ebook, right? That might be a case for fail closed. Because that ebook, if I say, here you go, but I never got paid for that thing, that's a problem, right? So, again, when we're deciding whether to fail open or fail close, we have to analyze the situation. We have to know our business case. We have to know the customer. We have to understand that this is not just a simple, well, let's default to this. We have to understand what we're trying to protect and how. So, oftentimes, fail close versus fail open behavior is not specifically addressed. This is not something where our business says, you're going to have to do this and fail open, right? This is usually left in the hands of us as the developers. And that leads to situations where error handling behavior can open up vulnerabilities or they can cause information leakage, right? So, generally not documenting the requirements because the clients don't know enough, or the design documents because our developers just kind of say, no problem, that's easy. So what this means in terms of application security is we have to flesh out requirements for explicit failure cases. If this is the failure scenario, this is how we want to handle it. And that means implementing common error handling routines. It means code reviews, not just for our code, but also for the error code, the error handling piece. And it means when we're doing our testing, we have to test for error conditions in addition to the stuff that we're expecting. Make sense? Questions? Cool. Let's talk separation of duties. Separation of duties is a key fraud control measure. This is something, if you guys do anything with Sarbanes-Oxley, segregation or separation of duties is kind of tantamount to that particular regulation. Separation of duties basically says that multiple authorities have to sign off on high-value transactions. So for me to do a certain thing, I need to have this person do something and this person do something. In the case of most organizations, what this means is things like the person who has the ability to enter new vendors does not also have the ability to pay vendors, right? Because if I have both of those duties, if I have the ability to enter a vendor and pay a vendor, what's to stop me from entering myself as a vendor and then paying myself, right? That's a fraud thing. It also means things like developers don't have the ability to deploy to production. Because again, developer can write the code that's going to run in production, put it out there, and nobody else signs off on that thing. So I know it sucks sometimes when you're going, man, I don't have the ability to push code to production. I have to talk to the web engineer, or, the internet team, or whatever. But that's the reason why. Now this is changing, especially with DevOps and the idea of continuous integration, continuous deployment, where we're creating pipelines that effectively handle this for us. So we can basically commit our code, the code goes through the pipeline, and the pipeline is basically our validation tier, right? And then it does deploy directly to production in some cases. But even in the case of those pipelines, typically there's a dev pipeline, a test pipeline, and a production pipeline. So as we're going through, there is a layer of approval. Somebody's actually signing off and saying, yes, this code looks good in dev, right? So let's move it to test. And it looks good in test, therefore let's move it to production. So there's still this separation of duties. A lot of times this also means administrators should also be users. So in certain organizations, you'll have a user account and an admin account. And you don't do your normal user activities like browsing the web and checking your email on an admin account. Likewise, you don't do Active Directory configuration on a basic user account, right? All right. So questions about separation of duties? Excellent. We will talk about the OWASP top 10. I will take a break, and I'll let Dan have a chance to speak for a bit.
All right.
Second.
How's everybody doing? Fantastic. All right, we're good. So any questions about any of the stuff that Josh talked through? All good?
Just out of curiosity, I just with Google Ads was talking in 2019 and 2017. Why are you using the 2013?
Uh,
2017.
I have a couple of answers, all of them cynical. As Josh said, but there are updated versions of the training that we offer commercially. The actual cynical worst answer is if you look at this list and compare it to the new lists, they're more the same than I would like them to be, especially for the higher end risks, like the injection flaws that we're about to talk about, the cross-site scripting and things like that. So a little bit of it is a convenience, and it's also, the scary thing is that a lot of this material is still, I don't want to call it evergreen because I think that is evidence of a forward-looking pessimism. But what we have seen is that, that a lot of the things that we were talking about back then, we're still talking about right now, which is a little disheartening. But the fact that we have all of you good people here today is encouraging because obviously you guys are going to go out and not make these mistakes. And hopefully you'll tell your coworkers, and they will also not make these mistakes, and so on and so forth. So, yeah, I mean, the OWASP Top 10, so the OWASP Top 10 has evolved over time, but the core issues that they're looking at are still there, which is a somewhat frustrating thing. There is an interesting, the folks at Veracode, I think actually just yesterday released, they have a document they released, I want to say annually or something like that, called the State of Software Security Report. White Hat Security has a comparable document that they released called the Application Security Statistics Report, I think. And you can Google those, and the Veracode folks released their, I think it was the 10th one that they released yesterday, and one of the graphs in there shows kind of the changes over time, the prevalence rate of certain vulnerabilities. And a big change that occurred in the statistics that they've seen is a decrease in the number of buffer overflows that they're finding. Buffer overflows were actually in the original OWASP Top 10 list and were pulled out of there, and that is reflective not of the fact that buffer overflows is a vulnerability class has been fixed, and we're still finding those. They're just not found as often in web applications. And so there have been some changes that we've seen over time as not a lot of people, especially these days, or even 10 years ago, were writing a lot of web applications in C and C++, or languages that are really susceptible to those type of memory errors. But the core stuff in the OWASP Top 10 are still, despite efforts of folks in the industry, are still issues, and especially when we look at the core stuff, injection flaws, cross-site scripting, authorization issues and things like that. Those types of issues still persist today, unfortunately. Great question.
Piggyback off that, the newer one, 2017, has XXC, which is more relevant to today because of microservices.
Right.
Are we covering that at all?
If we have some time at the end, we may be able to pull, I'll see if I can pull some stuff on that. Let me write that. I'll see if we have some stuff that we can pull up on that to talk about. Great question.
I recently saw somebody estimate the number of programmers in the field every 5 years, and we're basically still in the process of doubling the number of programmers every 5 years. So that means in general, half the programming population has under 5 years of experience.
Right.
And so, it's no surprise that we see a lot of these over and over.
Yeah, and this is also something that I had the great opportunity to do a TEDx talk in San Antonio a couple years ago that talked a little bit about that, and that's a challenge I think we see if we look at the universities that have traditionally been producing software developers. I went to Trinity University in San Antonio, and they're a liberal arts college, so I'm sure they would dispute viewing themselves as a vocational institute to turn out programmers for their computer science program, and that's fair, but that's the way I think a lot of people, at least immediately, use that type of education. Now we're seeing those, and what we haven't seen in a lot of cases, or at least in my experience with universities, is a strong ability to impart secure coding. If at best maybe there's a class on like crypto or something, which is certainly an interesting topic, but it's one where you're either like you know a little bit or you know a lot, and there's like a big gulf in between there. I don't know how much this is addressed in the coding academy type of boot camp types of things. And so that's a challenge, is I think that the pipeline we see for creating new software developers either through the university system, where I have a little bit of knowledge through the coding camps or boot camps and things like that where I have less knowledge. I don't know if the pipeline that we have for generating new developers is having a lot of success in providing people like this, providing the new programmers coming into the ecosystem with this type of training. I think it's a little bit better now than it was before, but that's, I think that's a serious issue, and it's also a challenge for the industry because then we see that from a continuing education standpoint, folks come to classes like this, which again, I enjoy doing this, and I think Josh does too. This is a fun thing to do, and it's, I think, helpful for the community. I think some employers have looked and said, like, hey, like this isn't something we want to pay for as a bolt-on. Like this is something that we want to see from the folks coming out of out of whatever vocational program they went through to become programmers. But there's some certain challenges with that. Like how many people are learning to develop web applications in university? Again, more now than before, but there's a lot of like data structures and algorithms and things like that overshadow. I sit on the board of Trinity with their comp sci department, and that's the kind of the constant struggle is, yes, we want to include more security. We have some student interest in security, but they don't really necessarily have professors that teach that at a technical level, right? They're, again, more crypto professors or folks that approach security from the Bell Padula model, from a more academic standpoint. So I think that's a real challenge that we see. You're right, like the population of developers is growing, so that when you look at the average entrant is a relatively recent entrant, and I think the on-ramps that we have for from a vocational standpoint for developers aren't doing a great job of teaching people about this. Yeah.
So with respect to that, the dearth of cybersecurity professionals is immense, and the number of open jobs is huge, and the money in it is tremendous. So why aren't those institutions adjusting themselves to demand?
Well, why aren't universities adjusting themselves to demand?
Well, I don't think you can do security in a boot camp. I don't think you can do development actually in a boot camp. But the institutions at least.
I have a theory on that, which is worth exactly what you're paying to hear it. My theory on that is that universities are competing on having better food plans and cooler Starbucks on campus, as opposed to on how they are preparing people to enter the workforce. And the availability of free money creates a situation where people pay a lot of money and don't necessarily go into the workforce with exactly what the workforce would want. That may be a popular opinion with some, maybe an unpopular opinion with others, but I think that is a challenge again that we have, is that the incentives for the people providing the education don't necessarily line up, and with a lot of money injected into that system, that puts folks in a situation where at least in the short term they can make decisions that aren't necessarily helping the market. But I think, I'll get these statistics wrong, but directionally they're correct. If you look at like the UT system of large universities in Texas. If you look at the size of the population of petroleum engineering jobs that are available, it's very large, but they're producing a comparatively small number of graduates. And if you look at the population of people or the population of jobs that require like a bachelor's degree in psychology, it's like vanishingly small, but the population of people that come out with those degrees is much larger. So I think that is a part of the problem. I also think that from a hiring standpoint, a lot of organizations look to hire into a certain level as opposed to being open to bringing on earlier career folks and growing them over time into those positions. And I think that's also responsible for some of the challenges that we're seeing in cybersecurity with the cybersecurity gap. If you didn't need to have like 10 years of any job category, if you didn't need to have 10 years of GRC, 10 years of web app testing, 10 years of penetration testing, 10 years of Sarbanes-Oxley to be considered for the job, I think that a lot of the job descriptions look for these like unicorn candidates that don't exist, as opposed to spreading a slightly wider net and being willing to grow people into roles. And I think that also creates that's also responsible for some of the imbalance that we see, where there's again, you have these positions, very high compensation, few applicants that make it through the screening process. I think that probably needs to be adjusted a little bit. Organizations need to be more open to focusing on looking at folks from a career path standpoint. Those are my opinions, not the official opinions of LastCon, OWASP, Denver Group. My parents probably don't agree with those. I don't know. That's just me running my mouth. So yes. Yeah, there's a link. When we go to a break, we can hop back to that link. Yeah, but these slides are all available from the OWASP site. Great questions. Any other? All right. Injection flaws. So one of the things that we quip in our office when working with organizations on testing their applications is like if a bad guy can run queries on your database, then it's not your database anymore, right? It's their database. And so what we're going to look at with these injection flaws is a pattern where for an application that you've built, you are, with applications, you're calling out to different interpreters, right? You're calling out to SQL database, and so you're passing a string over there, some sort of a SQL query that's going to be run, that's going to be interpreted. Or you're making queries to an LDAP store to pull, authentication and information. Or you're, again, running XPath queries against XML documents. All this general pattern of the situation where your application needs to feed something, or needs to get information or pass information somewhere, and it's passing this information over to some sort of an interpreter. And we're going to look at situations where an attacker can inject their own queries or their own, they can inject their own queries or their own code that get interpreted by these interpreters as code as opposed to data to be processed. And so the kind of most common one that you hear about, or that we talk about, is SQL injection, but this can apply to any situation where your system is going to some other interpreter and passing data over, where you're hoping to process that as data, but there's the possibility that it gets processed as not as data, but instead as code that the attacker gets to select. So, as I said, this occurs when you've got untrusted data getting sent to an interpreter as part of a command or a query, and this attacker's hostile data can then trick the interpreter into executing unintended commands or accessing data without proper authorization. And again, there's many different variants. The most common ones that we see: SQL injection, OS command injection, and LDAP. And the impact of these can be very severe. The injection can result in data loss, data corruption. You can take away the ability to do repudiation or to enforce accountability through the system. It can deny access. So if you think of a database that you're attached to, or if the operating system shell that you're running in, if an attacker can run their own queries in there, it's really kind of, again, subject to the level of defense and depth you've provided. There's a lot of really bad things that can happen. And it's important to look at and consider the business value of the affected data and the platforms that are running these interpreters. And again, this is a situation where all data can be stolen, modified, deleted, all sorts of an impact, really just subject to the attacker's goals, again, as well as some of the characteristics around the system from a defense and depth standpoint. So how does this happen? It can happen anytime you have an application that is accessing an interpreter. Major variations: SQL. Anybody here built a web application that talks to a database? Does anybody here only build web applications that are thin UI front ends on databases? Yeah, that's exactly. That's a large percentage of the web applications I've worked on in my career were database tables that you could navigate with via HTML. But it can also happen when you're talking to LDAP. If you're connected to LDAP, again, to do authentication. If you're running XPath queries to search through an XML document. If you're doing XSLT transforms. If you are generating HTML, we'll talk about a more specific case with HTML. When we talk about cross-site scripting vulnerabilities, if you're creating XML documents, and situations where you are showing out to an operating system command line. We're going to focus on SQL injection because it's the most common, with some information on OS command injection, but the important thing to take away from this is just that understanding. Anytime you're connecting, your application is using or accessing an interpreter, that pattern of interaction is the one where you should be concerned about being opened up to injection issues. SQL injection. This occurs when you build SQL queries from static text and unfiltered user input. So if we look here at, where we've got a string variable called SQL, and we've got select star from user where username equals. Then you pass in whatever, from a login screen, whatever the username parameter was from that text element. And the password equals whatever that password element is. And you of course, have to fix the quotes around those. From a developer standpoint, you probably expect something that comes in where the username is D. Cornell or Dan Denenberg. The password is password1 exclamation point, or something. Could be anything. But instead, the attacker is going to send in control characters that are going to cause this to be treated differently than you might expect. think I have a laser, so I'll have to talk. I'm just going to point my hand rather than a laser. So let's say that if we send in a username of apostrophe or 1 equals 1, you see when that static text that you had, that select star from user where username equals the single quote, when that gets appended to apostrophe or 1 equals 1 dash dash, then you also, again, append in and password equals whatever that is. When you take that query, right, and essentially hand it over to the database and say, hey, database, I want you to run this SQL query, instead of running a query where you say, pull any records from the database, and the assumption is that there's only one, where the username matches what I passed in as the username and the password passed in as the password, right? The way that you expect that query to work is to say, only give me the one row, if it exists, where the username and the password match what a person passed in. But when I append apostrophe or 1 equals 1 dash dash inside of there and put in a blank or an arbitrary password, what's the behavior going to be of the SQL interpreter when it receives that query down there on that second line there? Yeah, it's going to evaluate true because 1 equals 1 is always true, right? So the SQL query, the SQL interpreter, and these interpreters, they act like Pac-Man, right? So they start at the left end here and they chew through it. It says, select. Okay, we're running a select query. Chomp, chomp, star. Okay, we're going to select all of the columns. Chomp, chomp, chomp from. Okay, that's going to tell us from where. Chomp, chomp, chomp user. Okay, so we're going to get all the columns from the user table. Where, it's going to say username equals, okay, so we got to match the username. Well, the username equals blank or 1 equals 1. Okay, that's always going to evaluate to true. Then we have a dash dash that says ignore everything that comes after this on the line. And so the behavior of this query is going to be very different, right? In an interesting way, if you look at like the MITRE CWE and the way that they describe this, what they talk about is how an attacker is able to change the structure of this SQL query. And I think that's a really good way to look at it because you had a structure that you wanted to enforce for this query, right? I'm passing a username and I'm going to pass in a password and I want to get the row or rows, but I want to get the row that matches that. Great. We've been able to break the structure of this query because of the way it gets assembled, because we can say username equals blank or 1 equals 1. So we're able to change the way that that's going to be evaluated. And this is very common, right? Like that top line there that's select the SQL equals select star. That's a very natural way to write database access code, right? You're just thinking, okay, hey, I'm going to select and I want to be a little lazy. Let's just select all the columns, from the user table where username that matches this, password equals this. We got to put quotes around that so that it all makes sense. Great. It's a very natural way to write database access code. And to speak of, if we look at resources that folks use to learn, there are far too many answers on Stack Overflow. There are far too many, books or other online resources that have these types of errors or have these types of code that people just look at and cut and paste over, right? So very, very, very natural way to perform database access, but that results in a really, really damaging problem. And also, going back and talking about the defense in depth, a whole lot of applications have a very high level of permission on the database. Who here has ever written a web application that talks to your MySQL database as the root user or to your MS SQL database as the SA user? Obviously, no one in this class ever would. But some of your coworkers that aren't as bright as you, certainly, I would watch out for them, right? I've got a buddy who for a long time ran a company where they did outsourced development. He had his onshore guys that did all the design and stuff. And he had a bunch of offshore guys that did the actual execution. And he called me one day and he's like, man, I got a problem. We had this application that we built, and I'd heard about SQL injection. I didn't think anybody actually did anything with it. But we had the SQL injection problem, and now we've got to figure out what we need to do in order to clean up after this. And I said, well, they were using .NET or some sort of Microsoft-based stack. And I said, well, what users did you have that you're attached to the database? He's like, SA. This was a couple years ago. It was default configuration. Yeah, okay, well, cool. Well, the SA account can also via a stored procedure can run shell commands on the system, right? So you're going to spend a little bit of time like backing up whatever data you can, wiping servers, and trying to rebuild this system from the ground up in as clean a state as you possibly can. And so that's a real, this is extremely damaging because this is a very common way to craft database access, and because there's, in a lot of cases, not a lot of attention is paid to the level of permission that the database accounts have on the system. And so the impact of that can be really, really damaging. Where we see, so what can we do with SQL injection? We can short circuit queries, right? That's what we did before. We said, or add in an or 1 equals 1, right? That's always going to evaluate to true. Or 1 equals 2, you can make something always evaluate to, or and 1 equals 2, that makes something always evaluate to false. And so you can like change the way and kind of put your thumb on the scale of like which way the query is going to run. You can also retrieve confidential data. So you can run, you've got your select query, and then you can union that with another select query of your choosing. You can also potentially, if you can end this, the SQL query and add another, you can say drop table, delete from table, whatever that is. And so again, what you can do with the SQL injection vulnerability that you find as a bad guy is pretty broad, just looking at the vulnerability class. And then it's only going to be limited by, well, how is the actual query formed? And do I have other defense in depth things such as input validation, where we've cleaned out, we've cleaned out certain characters that makes it hard to do certain things, where we have limited permissions for a database user, whatever that might be. So really, really damaging. Potentially really, really damaging because, again, if I can't control the SQL that is being run, that gives me broad leeway as an attacker. And so if we think about this, what we've got is a situation where the attacker is sending things and they're proxying their attack through your application and then attacking the data in the database. Has anybody not seen this comic? No. Gotta love the XKCD guy for the stuff he puts together. No? So everybody should learn to sanitize your database inputs. As we'll talk about that, talk about exactly what we mean by sanitizing, because that's not just input validation. Another example here for anybody who might be worried about license plate readers. All right. So again, like when you look for what are the entry points for this. Again, anytime you have a situation where an application is connecting to an external interpreter. And again, when you look at IoT and things like that, what we're seeing are a lot more entry points to systems than you may have been used to. So let's look at that when it comes to operating system command injection. So this occurs when you're building OWASP shell commands from static text to unfiltered user input. So if you're shelling out via system.execute, where you're passing in things like this, and this is something like we don't see this as much anymore, just because now there are a lot fewer situations where it makes sense to shell out to go out to a command shell. This is something where when I used to run a company in the mid to late 90s doing some e-commerce stuff, and we had a script called shop.pl. That was a Perl script that would do shopping cart stuff, and this was before. And we eventually rewrote it to sit on top of a MySQL database. At the time, what it used for the data store was the catalog and everything was stored on the file system. And so it would, to do searches for products, you would do things like list this directory, get the entries that are back, and that's the list of categories that we've got. All right, list the items in here, and then those are going to be the files that we have for products and things like that. So I shudder to think, as far as I know, none of the stuff that we wrote way back then is still running, hopefully. Or it's all been moved to something slightly more modern, but we did a lot of work, shelling out and pulling listings of directories and listings of files and like that. We sent emails by shelling out to sendmail. So we did a lot of stuff by executing commands against the file system, because that was like a cool Unix way to do things. You have like a bunch of utilities that do small things well and you chain them together. Beautiful design philosophy, not a great one if you think about building web applications and attaching those to a bunch of really malicious inputs. So again, it's something we see. It's a lot more common in older legacy web applications. These days you've got open source libraries. Like if I'm writing a Java application I want to send to mail, I'm going to pull up javax.mail, which is a library that's going to connect to, it's going to talk SMTP to a server. I'm going to have a configuration. It's going to do it, via a library, right? If I want, if I'm building a shopping cart these days, I'm going to have everything stored in a, MySQL database or MS SQL database or some sort of a structured database, as opposed to showing up to the command line. That said, we do still see this from time to time if you've got to glue applications into to other stuff. And I actually found a bunch of problems on the Skype mobile app for Android. Had a bunch of challenges where they would shell out, like when you, this was a couple years ago, but when you would install the Skype Android application, it would detect your processor type and would drop different binaries on the system that, that it shelled out to do different Skype stuff, right? And so that's the way that they implemented it, rather than having like a native, Java implementation of whatever Skype protocol stuff they had. They just used a command line thing that they would recompile for each of the major processor architectures, and they would shell out to that and do stuff. They also put it in the file system so that anyone could overwrite it, so that's also negative, but it is, I got a call from the FBI about that. So again, it's still something we see from time to time in applications. If we look at LDAP injection, if you're dynamically building LDAP query strings, that can result in the same types of vulnerabilities. Right, where you're saying, I want to search for CN equals and then some sort of request parameter. Again, where the bad guy could send in things like wildcards or other control characters. So how do you test applications for these types of vulnerabilities? So this is the type of thing, these are the type of technical flaws that are in a lot of cases really easy to automate. So from a dynamic testing standpoint, what we need to know is what type of interpreters do we think that this application is using? Do we think it's using a SQL database? Do we think it's doing LDAP or it's doing authentication via LDAP? What type of interpreters do we think that we are going to find? And let's look for these distinctive request and response patterns, right? So I'm going to send in an apostrophe, and if I get back a JDBC error message, well, that's a good indication to me that however this thing is doing database access isn't set up right, because I passed in a character, right, that may be a perfectly valid character or not, but I passed in a character and I was able to cause some sort of error. That tells me that whoever built this probably hasn't done any testing with this application where they are properly handling single quotes, double quotes, other control characters. This is also the type of vulnerability that is usually that it can be really easy to find with code scanning tools, right? Because you can do you can do data flow taint analysis to say, where am I getting untrusted data into the system? Let me see as it gets appended onto other strings, and let me see if it gets passed to a sensitive sync function. So these are the types of things, again, that have very distinctive request and response patterns from a dynamic testing standpoint. They've got pretty strong patterns from a code analysis standpoint. So we send in these inputs that have these special or reserved characters, and we look for error messages or other exceptions coming back. And so SQL injection example, again, send in SQL control characters, single quote, double quote, semicolon, dash, dash, look for SQL-related error messages that come back. So if we look at crafting payloads, from an attacker standpoint, we need to do a little bit of guessing or reverse engineering of what we think the application is doing. Right? What do we think their code looks like on the server side? And then I can try to craft payloads that are going to take advantage of that. So if I've got something where I've got like a document ID and it's an integer, I've got select star from documents where document ID equals and then whatever the user passed in. Right? In a case like that, I don't have any quotes to deal with. In the example we looked at before, that login example, you may have to deal with some existing SQL where select star from user where the username equals single quote whatever I pass in another single quote. So as an attacker, then I'm going to deal with that starting quote before I can actually put my payload in, and then I'm going to clean up before the static text gets pasted back in, or before the interpreter gets to that. So if you'll remember the payload we used, it was apostrophe or 1 equals 1 dash dash. So that apostrophe takes care of the leading apostrophe. So where the username equals, Single quote, that's an empty string, that's still valid SQL. Then I put in what I wanted, which was or 1 equals 1, so that we force the query always to evaluate true. And then we put in dash dash saying ignore whatever else you see on this line, so we don't have to worry about all the password and the quotes around the password stuff. So what do we want to do with with a SQL injection payload? So many options. Again, we can modify an existing statement, changing the results of a where clause, pulling out additional data via union clause. We can potentially end the current statement and run another. Semicolons typically separate SQL statements. Dash dash is a SQL comment, so the rest of the line will get ignored. And then, if we can do that, then we can select insert, update, delete, all the SQL favorites. Again, the options are really limited by the imagination of the attacker, the constraints of your input validation, and the database account permissions. And the good news is, if you look at the configuration for the default configuration of the MySQL JDBC driver will, by default, not let you put multiple statements on the line. So they, from a configuration standpoint, there are some things that are done by default, or that you can additionally do to harden the system to say, right, hey, we're only ever going to run one SQL query at a time. Therefore, don't allow semicolons for multiple statements in a single, in a single query that's being sent in. And so. There are some things that you can do from a configuration standpoint to say there's going to be a limited amount of entropy in the SQL queries that we're sending. Let's constrain the way that the interpreter will actually look at this stuff. So mitigations. This is something that we'll come to probably for nearly all the top 10. One of our recommendations is going to be. One of our recommendations is going to be, there we go, to positively validate inputs. And so, looking for length, for type, for syntax, for business rules. One thing to note, input validation doesn't fix the vulnerability, right? Input validation doesn't fix the vulnerability, it only makes it harder to exploit. And that's, again, an important thing to understand. Because from an input validation standpoint, I might be concerned about single quotes, right? Like that's one of the kind of major characters that we're worried about if we haven't passed in. Worried about single quotes, but if I've got a registration form, I can't disallow single quotes, right? What about my good friend Brendan O'Malley from high school, right? He's got to be able to register, right? So he's got to be able to create a last name that has an apostrophe in it. So input validation can help to say, hey, we're going to limit this to a certain length so that we can't have huge, if an attacker finds a problem, they can't have huge things that they append onto it. We can limit certain characters. Maybe we don't want people to have emojis in their first name and last name. I'm personally against emojis across the board for a variety of reasons. But again, by constraining the length, by saying, well, this is supposed to be an integer, let's make sure it's an integer. This is supposed to be a positive monetary value. Let's make sure that it's that syntax and business rules. That's going to help constrain any issues that you do have. The real way that you solve this is to make sure that these inputs get treated as data to be operated on, not code be executed. And that gets down to the core concern from an injection flaw standpoint. You want to make sure that data passed in by the user gets treated as data, and that they don't have the opportunity to have that data treated as code. And so the way to do this is to properly encode the inputs before passing them to the interpreter, to some sort of an interpreter. And so that means in a SQL environment, if you've got a single quote, depending on the database driver that you're using, to escape that might mean that the single quote needs to turn into two single quotes, or the single quote needs to turn into a / single quote. Typically, the best way to do this, or to do this encoding, is going to be to turn it over to the folks who build the database drivers. And you can do that with stored procedures or prepared statements. You can also use ORM tools like Hibernate and Hibernate. Those also can provide some help with the encoding. And I'll show some Java and some Java-specific examples here in a minute. You also don't want to allow users to see verbose error messages, right? So how are we detecting those SQL injection vulnerabilities? send in a single quote, look at the JDBC error message that comes back. Okay, well neat, now I know that I've got some sort of a database problem, I pass in a database control character, great. If I don't provide those verbose error messages back to the user, that's going to constrain, it's going to limit what the attacker knows about the system. And it's going to limit, right? And some verbose error messages are going to show, here's the line of code, here's what the input looked like, all that's information that you don't need to pass back to the user. And also, again, from a defense and depth standpoint, you want to restrict account permissions. And so these database, database accounts used for web applications typically should have low permissions, right? They shouldn't be able to create tables or have other admin level uses. And if you spend a little time, you may be able to further constrain and say, hey, here are the tables that should be read-only, here are the tables that should be writable, and whatnot.
I have a question on the store procedure.
Yeah.
I have a developer who does implement the store procedure, but the store procedure itself allows dynamic processing. So what, from a developer standpoint, what use case would you need to do a dynamic query in the store procedure?
Yeah, so when would you need to do a dynamic query in a stored procedure? There may be cases like that come up. I've seen, and we've run into trouble building stuff where you have queries where the vast majority of the queries that you need to execute fit into a very narrow set of boxes, right? There's very low entropy of what should be coming in for your SQL queries. It's, hey, I need to search based on this term or these two terms, or I need to search data in these columns. We've seen situations when you're doing more like dynamic searching to say, on this field, when you're exposing to the user the ability to search on more things, that can be a situation where that might be justified. And when I look at those sections of code, it's like very security critical code anytime you're allowing any type of behavior like that. And so I suspect if you go to that developer and look at like where are the situations where you feel like you need to do these dynamic queries, that can be refactored out to, you're writing this one general routine for like these three things, but we can't properly secure that, so let's just write three stored procedures that handle those different search queries. It's going to depend on your specific, on your application and on the use case. But any situation where you're allowing folks or where you feel like you're backed into a corner where you have to be allowing for these dynamic queries, again, that's a situation where you want to, identify those and you want to audit and treat those in a very special way because, typically it is vanishingly small the situations where that is the appropriate solution to the problem. And in a lot of cases, the developer trying to be clever and save some time, which I'm a developer and I'm lazy and I can respect that. But looking at how hard it can be to secure those situations with input validation or with putting your own coding in there, that's something where we usually look to refactor those to see what's really necessary here.
I'm going to see changing things, and if he is, start to see them separate. That's mainly where you can see that.
You developers will do it all over the place, right? Anytime that they think they can. Because I've looked at systems in the state of Oklahoma, had something like this with I want to say the sex offender registry or something like that, where they just had basically a page that was pass me the SQL query and I'm gonna run it and put it in a table and echo it back to you. Right. So if you think from a pure development standpoint, that's reusable code, right? What report do you want? Great. Just when you tell me the reports that you want, we'll just create the parameters, pass it into the SQL query, get the results and stuff at the table, right? So from a usability or from a development standpoint, that is very reusable, very easy to do. From a security standpoint, that's indefensible, right? You have no ability to constrain that being used outside of the bounds of how you want that to be used. And so, any situation where you have a developer that, even though they're using stored procedures, they're also dynamically crafting SQL inside of there. That's a situation where I typically look to refactor. What's the real reason for doing this? Is that because we don't understand our requirements such that we need this level of flexibility? Okay, well let's nail down our requirements and talk about here's the 5 reports we want. Let's make those reports not just have a page where you pass it a query and it just dumps stuff back. Yes.
Yeah, I was just at a meeting yesterday where 2 people said that they had problems with ORMs in general. They want to write their own because the ones that are available give them problems with your code. So even though it says do
Yeah, so I mean, the question is, so, you know, for people that don't like the existing ORMs and want to write their own, developers also like to write their own crypto, and it's a bad idea. You know, and so I certainly have suffered at the hands of Hibernate mightily in my career, you know, and so I understand that. You know, I think it's also a question, just from a general management standpoint, is you know, just in general, a lot of times developers like to write their own stuff, and that is often, in general, not the best use of their time, and a better use of their time would be to use Hibernate for the 95% of the time it works great, and use not Hibernate for the 5% of the time that it, you know, where you actually do work around that. Yeah, that's you know, independent of security, that is a recommendation that I might make, again, depending on your tech stack and your specific requirements. You know, in a lot of cases, you know, to the degree that you can use code that other people wrote, especially code that's been through, you know, enough scrutiny, you know, as the really popular projects like a Hibernate or other things like that. You know, in general, that's going to be your better bet because they're going to have spent more time optimizing performance, you know, solving the various corner cases, and you know, auditing the security important or security critical aspects of the system. And so, you know, certainly I can appreciate that some developers want to write their own stuff. As a person who manages developers, I also appreciate that occasionally you've got to tell developers to suck it up and like do what you tell them for the good of the project, and especially again when it comes to a lot of security critical stuff.
So what is it, what's the problem really? What's the problem that?
I mean, so yeah, the question about like what Hibernate, why we like to avoid it. You know, what we've seen, or what I've seen from you know, the challenges with Hibernate, and this is independent of security, the challenges I've seen with Hibernate is that for really large queries, the performance characteristics can get bad, and you know, especially when you end up with more complicated, deeper queries, you either end up with like really like a whole bunch of queries being run against the database, or like a whole lot of memory being required for the stuff that they're doing. And again, those are situations you typically need a profile to identify, and then hand code those specific situations. You know, they may have other objections to Hibernate, but those are kind of the most common ones that I've seen with the object relational management systems. Is like, hey, it's really easy to get up and running, and you know, get our first couple of screens or first couple of use cases built. But then when we get into really complicated stuff, or where we're doing like large data management things, that Hibernate doesn't work. You know, my response to that is usually like, okay, cool, let's like find out what we need to do to optimize Hibernate or work around Hibernate in this specific case, because the like stability and performance, the stability and developer productivity benefit you get outside of that for the ORM is going to far outstrip wanting to write your own code from the ground up. Again, it's going to depend on your tech stack and your team and the application, but that's kind of the most common complaints that I hear from folks about using some sort of ORM is, either it requires too many queries to do stuff so it runs slow, or it requires a bunch of memory to blow stuff up. Those are typically edge cases that you can work around. Excellent. Question? Okay. So we talked a little bit about this stuff in a Java-specific environment. You can use prepared statements or callable statements, which are what Java refers to as stored procedures. And so, what prepared statements allows you to do is to craft your query to say, I want to update coffee to set the sales equal to something where coffee name like something, right? And then we say for the first, and I don't know why this is one index rather than zero index. Java people, come on. But we say, hey, I want to set the first parameter as an int to 75. I want to set the second parameter as a string to Colombian. What that does is it turns over to the JDBC driver and says, hey, JDBC driver, I want you to execute this query with this structure. Remember, that's what we talked about before, so controlling the structure of the query. Here's the structure I want for the query, and here are the two variables that I want to pass you. And so if I pass in, Columbia, apostrophe, exclamation point, dash, dash, whatever, it's the responsibility of the JDBC driver to say, I need to encode this properly so that that's going to appear in the query as data to be fed into the query, data to be processed, as opposed to code to be executed. And so, what ends up happening is that the JDBC driver, 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 the JDBC Similarly, you can use Java callable statements and say, hey, I want to call show suppliers, and I want to set the first parameter as an int to 75, second parameter as a string to Colombian, execute the query. And you brought up a great point which says, just because what this does is this makes sure that data gets to the stored procedure, treated as it should be, treated as an int, treated as a string. If the first thing you do inside of your stored procedure is say, I want to create a string called SQL where I say, select star from whatever, where this is this plus this and this equals this plus this, you run into the exact same problem. And so, again, the stored procedure are handy for when you want to pass in the variables, but if you then inside of the stored procedure just like append a bunch of strings together and then execute that SQL, like you've created the same problem, you've just written it in PL SQL or T-SQL rather than having written it in Java. And so the pattern that you want is to make sure that those variables are treated as variables. And finally here, from a Java-specific standpoint, we want to control error messages. So in your web.xml, you can go in and indicate in the error page tag, error codes and location of the resource to display. And so again, what you don't want is a behavior where anytime an exception gets thrown, you pop up a 500 page with a stack trace and all kinds of verbose and stuff. You want to control those error messages and make sure that you're saying, hey, an error occurred with no specifics, right? Like from a user standpoint, there's not a lot of decisions they're going to make that are going to help you. You probably want to log the error on, from an operations standpoint, you want to log that and have access to that. But the user shouldn't see it. So to recap, injection flaws occur when you have unfiltered user inputs. They get combined with static text, and the result gets passed to an interpreter. There are a number of varieties. The most common, and again, the one we looked at the most was SQL injection. Also issues with LDAP, XPath, OS command. As with everything we are going to say, you always want to positively validate your inputs. But the way you actually solve the problem is you want to escape any user-supplied data before sending it to an interpreter. So again, that's making sure that the data gets treated as data, not as code to be executed. You want to restrict attackers' access to error and debugging information. And you want to practice defense in depth, limiting the permissions of the accounts that are accessing these interpreters. There we go. There are some references again. The slides are available, so you can look at the various information there. Now, I think it makes sense to take probably a 10-minute break. Yeah, 10-minute break, so we'll be back here at 10:41 to talk about broken authentication and session management. Actually, before, any questions? Sorry, I think we just covered it. Yeah.
Just one quick one, Java-based. The error message is more recommended to use the logger library as opposed to the throw catch exception E.
That depends.
Instead of
Yeah.
using that case, they prefer to use the logger library as opposed to the traditional throw catch.
I would get throw catch. I would log the exception. Via logger.
Yeah, just the logger being implemented into that.
Right.
Redirect it somewhere else to like a log server or something.
It depends on operational what you guys are what you're doing. We've done things where we've also stored those in a database so that we can go and look through the errors if we need to track them down. But yeah. Thank you. Oh yeah. So the question was for like in Java the preferred method. Do you want to use the logging libraries to log the exception message, or do a try catch? And typically you want to catch the exception, log the exception, then gracefully handle that. But then also to have that configuration if some other part of the program throws a 500 or something like that, to make sure in a situation where something happens you haven't caught that you're still showing a page that doesn't provide the attacker with any additional information. Cool. Thank you. I'll see you in just a couple minutes.
Yeah, Yeah. Send them a text, even if you can't get around to it.
Move forward. Someone said everybody's doing
All right, guys, go ahead and get your drinks, finish the conversations, take your seats. Awesome. Moving right along, guys. At this point, we've covered some security basics, basic security principles. We covered the input piece, injection clause, and now we're going to talk about broken authentication and session management. Before I dig into that, are there any outstanding questions? You guys had a little chance to think through things. Nothing. Okay. All right. So let's talk about broken authentication and session management. The idea here is that if you're not sure who's using the web application, how do you know they're not bad guys? So this occurs when applications fail to properly protect credentials and session tokens throughout the entire life cycle. The attackers will attempt to exploit a variety of different factors. So there could be session IDs that are passed unencrypted. Historically, we saw a lot of web applications that would have like a session ID passed in the URL, and if that URL was HTTP, not HTTPS, or if that information belonged to logs, things like that, you would be able to get those session IDs. And the session identifier, typically what happens is the session identifier is a representation of your username and password. So when you connect to a web application, you are going to authenticate with a username and password. From there, what's going to happen is that web application is going to drop a cookie onto your system. That cookie has a session ID, and then the system itself, the server, is going to know that session ID as well. And those two pieces are basically what ties you and the fact that you've already authenticated with your username and password to the application. So as long as that session identifier is valid, if somebody could sniff that session ID, if they were able to get a hold of that credential somehow, they would then be able to act as though they were you on that application. And so it makes it incredibly important that we protect that. In some cases, this could mean that the user credentials themselves were passed unencrypted. So in this case, this is when you're at that login prompt, it's got the fields for the username and password, and you hit go, and those credentials are passed in clear text. Fortunately, I think this is something that we're doing a much better job of today. Most of the applications that we see, at least the ones that are internet facing, are HTTPS, but this still ends up being a pretty big issue within our corporate environments. So in our enterprises, there are a lot of organizations that do not protect their applications using HTTPS, and that becomes a big issue. On the internet, there is absolutely no reason why you should be running an application that is HTTP and not HTTPS. And why I say that is because, one, you've got Let's Encrypt. Let's Encrypt is a project that basically gives out free HTTPS certificates. They've got processes for automated rotation of those certificates. They're valid for 90 days. They're actual browser validated certificates. So if I were to put a website up and didn't use HTTPS, I'm doing myself a disservice. And the reason why I say that is because search engines, Google for example, are actually now de-ranking sites that don't use HTTPS. So if your website uses HTTP by default, does not redirect users to HTTPS by default, you will actually be dropped in the search engine rankings as a result of that. Take that information back to your companies. That is a big thing because most of the time our companies want to go up in their rankings, and making our sites HTTPS is a great way to do that. It's an almost free way to do that, right? The last example here is poor username and password recovery functions. And what we mean by that is it's the forgot my password functionality. And every once in a while, you will come across a website where you click forgot my password, and they will actually email you the password that you had sent. That's bad, right? We'll talk more about that. So the impact here is severe. These flaws can allow some or even all accounts to be attacked. Because as soon as we start doing this, as soon as we start basically giving away the credentials or giving away the ability for somebody else to log into our application, now they're able to gain access to the data and things like that. And once successful, the attacker can do anything the victim can do because they are logged in as that victim. Privileged accounts are frequently targeted here because privileged accounts have privileges, right? So these are users that kind of go above and beyond the basic users. And anytime that we're looking at something like this, we should consider the business value of the affected data or application functions and the business impact of public exposure and vulnerability. And what that means in this case is we're looking at it and saying, okay, what is this website? What are the credentials that we're protecting here? What's the data that we're trying to protect here? And what's the value or the issue if this data were to be compromised? And there's multiple different variations here. So in some cases, it could be the attacker sniffing network traffic to recover sensitive data. There was actually a really good, really cool program called Firesheet. Any of you guys ever heard of this? So Firesheet was a plugin for the Firefox browser. And the way that it worked is you would basically install that plugin and you'd sit at Starbucks or some coffee shop on the wireless network. And this is probably 15 years ago, something like that. But what would happen is, back then, nobody used HTTPS. Everybody used HTTP. And you would basically be sitting there, and Firesheet just monitored the network traffic. It just looked at the network traffic. And what it did is it waited until somebody logged into Facebook, to Twitter, things like that. And as soon as they did that, what it did is it captured that session ID. It captured that information. And then for me, the person running Firesheet, it said, hey, capture new credentials, would you like to log in as this user? And you literally just click log in, and now you were that user. And as long as that session was valid, so basically until the user clicked log out or until that session timed out, you were now able to use those credentials. So, if an attacker is able to sniff network traffic, if your data is not encrypted, this attack still very much works. And this is why I say everybody on the internet, everybody with public-facing websites should be moving to HTTPS, because that's how we kill this attack. This can work in a couple of different places. It can work on those session IDs. Again, session ID is just a representation of the fact that I have now authenticated with the application. Or it could work on the user credentials themselves. So if I have username JSOCL, password, and hit submit, and that's going over HTTP, and somebody's anywhere between my browser and the server, they're going to be able to see that credential. It could be a case where an attacker guesses valid session identifiers. And so this is the reason why it is incredibly important when we're generating session IDs that we're doing it in a safe, secure way. Most of our application technologies will create a session ID that is long and is random. And then it will invalidate that session ID after a timeout period. If we are not doing that, if we don't invalidate the session ID, we're basically saying, hey, attacker, you have an infinite amount of time to guess this, right? So length and complexity is going to factor in there in terms of that. The attacker could exploit a vulnerable account management functionality. So this is the example that I gave you before with username recovery, password reset, things like that. All right. Has anybody here heard of WebGoat? Yeah, we've got a few. Awesome. So WebGoat is an OWASP tool. WebGoat is a really good training environment if you want to learn about web application vulnerabilities. And it's something that I've used in my training. It's something that I put my developers on and say, all right, you've now learned about this. Now you get the opportunity to play with it in person. We're not going to do this example, but as I mentioned, when I'm doing this training for my developers, we couple the slides with the hands-on. So this is just one example of that hands-on activity where basically what they're doing is they're, in one case, they have a authentication cookie. They give you 2 users and the passwords, and so you can look at those cookies and you can examine what that session identifier looks like. And then as you go through that process, you realize that they are just generating a cookie by reversing the user's name and putting that in there. And I think they have like 1, 2, 3 or something like that after. Not a good way to generate a cookie, not long, not random, right? But what that means is that I can guess that cookie for any valid user. That becomes a problem. In the authentication flaws, they leverage the forgot my password functionality in order to do that. Kind of interesting story here. So, anybody remember Sarah Palin? She could see Alaska or see Russia from her house, right? So Sarah Palin, back when she was running to run for president, she had, I think it was a Yahoo account, and a hacker actually hacked into her Yahoo account. And the way that they were able to get access was actually through one of these forgot my password functionalities. The way that they did this is they actually asked questions or answered, or the user had to answer questions in order to get access to the password. And so with her, one of the questions was, what kind of car do you drive? And the options were like Mercedes, Ford Pinto, a pickup truck or a Toyota Camry, something like that. And you start looking at it, you're like, well, I could probably search pictures on the internet, I could probably get some information about her. It's probably not too hard to figure out what kind of vehicle Sarah Palin drives. And so that's exactly what the hacker did. They figured out what kind of vehicle they drove, took an educated guess, basically, and sure enough, they were right. They were able to reset her password and access her account. So these kind of things are incredibly important. This is also the reason when we're doing forgot my password functionalities, the best questions aren't questions like, what's your mother's maiden name? Those are things that I could actually look up. That's data that I could probably get from some sort of a registry, maybe a marriage certificate, things like that. The best questions are questions that are self-made. You can actually use a password manager, create your own questions, and then store the answers to those questions in your password manager, right? So consider that. Now, how do we test applications? Testing is usually pretty hard to automate with any sort of stack or dynamic analysis. Stack analysis, in case you haven't heard of it, also referred to as SAS. Stack analysis is basically scanning the code. So we're basically running an application that looks through the code, it looks at where data goes in, it looks at how data comes out, and it determines vulnerabilities based on what we call sinks and sources, so those values. Dynamic analysis is scanning the application itself. So think of it as like our web application, you've got a bunch of form fields, buttons, whatnot, and the dynamic analysis tool, or DAS, is actually filling those form fields out with data. It's clicking submit buttons, and it's looking at the data that gets returned. So, in this case, broken authentication is pretty hard to figure out because the computer isn't really good at finding proper session IDs. It's not really good. It can probably determine if your site is running HTTP versus HTTPS, but it's not really good at the password reset flaws, things like that. They rely, it relies too heavily on business logic that our scanning tools just don't understand. So the way that we test for this is by using threat hunts, and we target manual attacks. So we will look for like attack vectors, and then we will verify that they're not successful. So for example, we might log into the application and look at the session ID and say, is that session ID long? Is it random? If I log out and log back in, do I get the same session ID again? Or am I getting a different session ID, meaning it is being randomly generated upon each login? Those are the kind of things that we want to look for here. In terms of technical mitigations, if your platform has it, use the built-in session management. These session management routines, so for example, if you're doing Java JSession ID, These built-in session management facilities are designed to create those long random values that are changing with each login. Those are not going to have these issues. If you decide to roll your own, all bets are off. And in all likelihood, I'm going to bet on the fact that you probably do have issues. Sammy Kamkar did a talk here at LastCon back in 2010, where he talked about, the talk was called How I Met Your Girlfriend, I think. And he basically talked about broken session IDs and how he was able to guess session IDs in PHP because the values were properly randomly generated. It's kind of interesting. We should avoid using any sort of custom cookies for session authentication purposes. So putting things into cookies like, hey, user ID is this. Cookies are under the control of the user. And so if the user has access to the cookies, that means that they can change the cookies. So if you have a cookie that has a value that's like admin equals 0, and I'm the person testing the application, what am I going to do?
Admin equals 1.
Admin equals 1, yes, right? Of course, I'm going to set admin to 1 and see what happens. And all of a sudden, maybe I have an admin account. So those are things that we want to keep track on the back end. We want to keep track of that in our database, in our configurations on the back end. The other thing that's incredibly important is building secure logout facilities. And the reason is what I said before. The longer this session is active, the more time somebody has to brute force the session. And so by building secure logout facilities, it means destroying the session and validating that session ID. Nobody else can use that at that point. This means putting session timeouts there so that that session will automatically time out after a certain period of inactivity. And it also means that logout links should be available from every page. I actually have a buddy who's developing a website, and I sent him a note yesterday because I was messing around on his website, and I could not, well, eventually I figured it out, but it took me probably 3 minutes to figure out how do I log out of his application. The natural place, the place we're all used to the logout being, is what? Top right. Yeah. And sometimes it's hidden under some sort of picture or profile or something like that. But you immediately go to the top right, and in the top right, there was a picture of me up there. And I clicked it, and it took me to my profile. And I was like, log out, where are you? Not on the page anywhere. Eventually, I figured out that I had to go to the top left where there was a menu button. I clicked the menu button, and now at the very bottom of the page, in the middle, there was a logout button, or a logout link, right? Is the average user going to search that out? No. They're never going to find that. They're going to get so, they're going to start with the top, they're going to click that button, and when they don't see a logout, they're going to close the browser, right? And now, if we don't enforce any session timeouts, an attacker could potentially brute force that session time, right? So it's very important. We've all been trained. Look at the top right. Your logout link should be there. All of our applications should enforce that. The next one here is don't put sensitive data in URLs or logs. And if you put it in the URL, oftentimes it's going to end up in a log. Sometimes this will also end up in some sort of caching server. If you have a proxy between it, that will cache web pages and things like that. Sometimes it'll end up in there. Sometimes it'll end up in your browser history, so somebody can recall the session ID that way. In any case, we don't want to put any sensitive data, like a username, like a password, like a session ID, in that URL. That should actually be in our session, right? Yeah. Don't rely on unreliable factors for authentication. You can use these as supporting factors. So for example, I could say that that particular user always comes from that IP address, and I could use that as a supporting factor, but that is not the only factor. If I say that only users from that IP address can hit my application, and I provide zero authentication beyond that, somebody can spoof their IP address and hit my application. Or if I have one of my systems compromised, one of the systems on that IP, behind that network, whatever, gets compromised, they have access to that application. So, usernames and passwords. You can use these additional factors like IP address ranges or refer headers, things like that, as supporting, but definitely do not rely on them. They are unreliable, they're under the control of the attacker, they can change those things. In terms of business logic design, there are some mitigations we can put here as well. You can require users to enter their old password when they're updating their password. As a user, this is kind of annoying, right? Because you're going, man, I want to change my password. You click on change password, it's like, what's your old password? Shit, I don't remember what it was. Or, you know, I just clicked save when I saved it into my browser. Bad practice, by the way. But by forcing them to enter their password, their old password, before entering the new password, what we're doing is we're really validating that they are the user, that they have not brute forced the session to gain access to change the password, right? So by forcing them to re-authenticate, we're basically forcing that, that transaction. We're ensuring that they did not get there through some other means. The next one is using strong secondary authentication factors. And what this means is our password reset question should be freeform rather than standard. We can use multi-factor authentication, things like secure ID token, SMS message, things like that. SMS, by the way, gets a little bit hairy as well. There was a interesting article not too long ago about a guy who had millions of dollars in Bitcoin. I don't think it was millions, hundreds of thousands of dollars in Bitcoin. And he used SMS as a second factor of authentication. Somebody actually became aware of that. I think he was bragging about it, which is also a bad idea. And what they ended up doing is they spoofed his SMS. They were able to, or cloned his SMS. They were able to, they got his password. They were able to log in. They received the SMS clone. So they received that second factor of authentication message, and then they entered it, and then they transferred all his Bitcoin. And there was nothing he could do about it at that point. So, best thing is to use some sort of token. There's tons of different programs. Duo actually has a great program for your phone that'll do it. There's Google Authenticator, there's a Microsoft one. But using some sort of time-based token where every 30 seconds, every minute, the token is going to change, that's probably the best route to go with something like that. Always be careful when you're sending information via email. And the reason why I say that is because email is clear text. Emails should have random identifiers. The random identifiers should expire after time and upon use so that somebody else can't use it again. And you want to notify users of the account changes. So if I need to do a reset and I have to send an email to somebody, it basically is an email with some long random value that's good for 10 minutes, 15 minutes, whatever, so that when they click the link, they can reset it. What I'm doing is I'm authenticating that they are the owner of that email box. That I make it a timeout value so that somebody doesn't brute force that identifier. And then I send them a notification saying, hey, just FYI, you changed your password. Right? So if they didn't intend to do that, and they did get brute force or something like that, they can go, oh no, that wasn't me. Right? And they can take action. Questions about any of that? Yeah.
I require my developers to set an anonymous cookie when they reach a splash page login, or just require after the login.
Set an anonymous cookie. What kind of application is this?
Just the website that they're going to. So they reach a splash page of login form. A lot of companies would set an anonymous cookie that would then be used for that particular page. And when they log in, obviously describe the old one issue new one.
Yeah.
Is that a practice of requiring them to have it today?
It probably is a good practice. So oftentimes what ends up happening is you want to have a different session identifier when you hit the page than after you're authenticated for the page. And for that reason, we'll rotate those session IDs after the authentication piece. It's kind of interesting. If you go to like Amazon.com as an example, they will set a cookie when you first hit the site without even authenticating. And that cookie they use to kind of track you as you're going around the site, as you're adding products and things like that. And then once you log in, they'll do exactly as you said. They will actually switch your session ID, you authenticate, you switch your session ID to now an authenticated session, and then they move all that stuff into there so that you still have the products that you've selected and things like that. So yeah, it's probably a best practice to switch that session ID after you've actually authenticated with the application. And especially a good practice if you're doing HTTP at any point leading up to that authentication, because at that point your session ID is already compromised.
Well, I'm not talking about switching, I'm talking about at the beginning, because obviously the knapsack engineering, you have to think about development. So should I focus more on what you just talked about, switching ID, or should I focus on what Amazon does, when you arrive at the page, there is a tracking cookie, there is an anonymous cookie being set. If they don't set anything wrong, should I be careful now?
I mean, you only care if you're trying to track them, right? The whole point of the anonymous cookie is that there are activities that the user is taking prior to the authentication piece that you want to be able to track after the authentication piece. So the anonymous cookie, if there are activities that they're taking anonymously that will carry over to an authenticated session, then absolutely. If it's something where I've just hit the splash page, there's nothing really there to track, but now I want to authenticate them afterwards and then give them a cookie because I have to track their roles and permissions and things like that, then you really wouldn't need the anonymous cookie. To answer your question? Okay. Do you have a question about it?
And that's, as a consumer of websites, where you don't have control over that secondary authentication, you should provide smart-ass answers, like where were you born, Earth, or where did you go to school, hard knocks, and put them in your password manager so that people can't reverse engineer.
Yeah, absolutely. So I'll repeat. What you said is that anytime you're saying those, the password reset questions, and let's say you are locked into certain answers, right? It's what is your mother's maiden name? Don't put your mother's maiden name in there because again, that's relatively public knowledge. Use your password manager, generate a random answer, and then store that in your password manager. So now your reset is uppercase, lowercase, numbers, special characters, whatever. As long as your password manager is good and you have access to that, then absolutely you can do that. You can reset with those values. So anytime that helps to avoid the Sarah Palin approach, right? Where somebody can potentially guess that. It's a good comment. Yeah.
I've seen before that some developers would forget to update the session identifier after a password reset. So without the case.
Okay.
Take that identifier.
Yeah, so what he's saying is that after you do the password reset, your password reset process, the idea is that perhaps your password has been compromised or something like that. And you should probably assume that your session ID is also compromised in that case. So when you do a password reset, you should also reset the session identifier to something new when you take that activity. It's a good observation too. Anything else? Yeah.
What's a good password manager?
Good password manager, so I absolutely love KeePass. I think it's fantastic. It's going to be a little bit harder than some of the online managers like LastPass or something like that. But what I typically do is I will use some sort of a drive sync or drive sharing application, Box, Dropbox, Google Drive, whatever. I will keep my KeePass database in there, and then that allows me to sync it back and forth between my phone, my computer, whatever, and then use KeePass to actually open it. KeePass has an option for a key in addition to a password. That's a good thing. What that does is that ensures as long as you keep your keys separate from the repository where the password database file actually is, that means that even if somebody compromises that, remember the defense in depth conversation, even if somebody were to get access to your Dropbox, Box, whatever, they don't have access to that password database. Even if they have your password, even if they have access to that, they don't have your key. So again, defense in depth. There was another, yeah.
So here we're talking about passwords and tokens, which is what you know or what you have. There's also take on biometrics, which is what you are as a form of authentication.
Okay. So the question is, what's the take on biometrics? So passwords can be three things. Something you have. So for example, a token, my phone, whatever. Something you know, which is what we typically think of with a password, and something you are. Biometrics. That's fingerprints, thumbprints, retinal scans, handprints, whatever, right? They're doing voice recognition, facial recognition, things like that. So what's my take on that? I think biometrics is interesting. The challenge that we have with biometrics is that a lot of those factors are really hard to, they're hard to nail down, and then once you nail them down, they never change. And what I mean by that is my thumbprint is my thumbprint, right? And unless if I'm going to burn off my thumbprint, that exists. So the fact that I have a glass over there, that has my thumbprint on it. And anybody could potentially get my thumbprint and replicate my thumbprint and use it, right? My biometric authentication mechanism is now effectively useless because everybody has access to it, right? I think that as a multi-factor authentication mechanism, it's good, right? It definitely gives us a leg up on, I just have the password. But I mean, we have all seen like the Bond movies where he kills a guy and then cuts his eye out and then holds it up to the thing, right? There definitely is a downfall there, right? Whether somebody's going to actually do that probably depends on the value of the data that you have in, right? If it's you're guarding Fort Knox and I get millions of dollars worth of gold by cutting somebody's eye out, I don't know, maybe I'm going to do that, right? So, yeah.
From a legal standpoint, this is very important, because you can be compelled to unlock your device if it's a biometric, but if it's a password, you cannot be compelled. So if you're gonna use your fingerprint to unlock your phone, then at least have the drive encrypted so that it requires a password when you boot the phone.
So what she said is that from a legal standpoint, you can be compelled to use a thumbprint to unlock your device. You cannot be compelled to give them your password. And I'm not a lawyer, so I don't, one way or another on that. But what I will say is there are some cool applications out there. I think it's called VeriCrypt is the new version of TrueCrypt. One of the things that VeriCrypt will do is it'll encrypt your disk. So if you're in Windows or something like that, it'll encrypt it. It gives you the ability to have a secondary partition and 2 passwords. So what you can actually do is have 2 versions of Windows running on that disk. If you enter one version of Windows, it's going to unlock the one that you actually use, or one password, it'll unlock the one that you use. If you enter a different password, it decrypts the one that you want them to see. And so I'm not advocating for or against this, but if you were in a situation where somebody was holding a gun to your head and saying, enter your password now, right? Something like that might be a good out. I'll give you another kind of similar example. A lot of people don't know this, but your alarm code, if you have like a burglar alarm on your house, there's typically a code which is 2580 straight down the middle. That is the panic code. In a lot of systems, you can change that to something else. But the whole idea of the panic code is when somebody is standing at your door holding a gun to your head and saying disarm the alarm, right? You can enter a code that turns off the alarm, but the police still come, right? So I don't know if that's the long way to answer the question or to elaborate or whatever. Interesting side note, I guess. Other questions? All right. So in terms of Java-specific safeguards here, the best one is just use the J2EE web session management from your application server. If you start rolling your own, that's where you're getting into trouble. I've noticed a couple people taking pictures of the slides. Totally cool, feel free to take pictures. But we posted a link at the beginning of this presentation. We'll share it with you again for the presentation. You can download it, you can use it to your heart's content. We're happy to share that. So don't feel like you have to take a picture of every single slide up here. That sucks. Yeah. Basically the same thing. Java Enterprise Edition. All right. So to recap here. Many web applications have both technical and business issues with the way they handle user authentication and session management. There's a number of ways that these vulnerabilities can surface. We have the sensitive information passed over HTTP rather than HTTPS. Hopefully you all will go back and change all your applications to HTTPS to use Let's Encrypt. The world will be a better place. Google search engine rankings will go up. Guessable session identifiers or other authentication-related tokens. Again, you're going to use the built-in session management functionality and hopefully fix that. Problems with logic and account management functions, you will fix the logic. You'll make sure that password reset questions are handled appropriately. And again, they guard against it. We want to use the built-in capabilities and think through the business logic. So with that, here's some references. OWASP has great cheat sheets, by the way. So if you search like OWASP cheat sheet and then some topic that you're looking at into Google, the first link should be to the OWASP cheat sheet for that topic. It's fantastic. It walks you through, here's the problem, here's the solution, here's how to test it. Really, really cool resources. Asapi is interesting. I don't think people are currently working on it, but Asapi was the enterprise security API. The whole idea was that OWASP was going to write this code for you that handled all the complicated security stuff, and then you just call those routines through the API in your code. The reality is that the API, the Asapi, actually had a ton of vulnerabilities in it itself, and so it's interesting. It's a really good resource if you're trying to figure out how do I do something, but I don't know a lot of people who are actually using Asapi today. Lots of OWASP developer guides, testing guides, and then I mentioned the WAS. Here's the CWE on improper authentication is what it's called. So 1118, we have two choices. We can talk about cross-site scripting. I think that's about a 30, 45-minute conversation, so we probably finish right at noon, something like that. Or we can go to lunch early. We are not serving lunch here. You guys are responsible for your own lunch. But there are lots of different restaurants right around Norris here, so lots of options for you guys. So we are going to take a vote. It'll be a democratic society. If you would like to break early, or i.e. right now at 11:20, and go to lunch, please raise your hand. If you would like to continue and do cross-site scripting, please raise your hand. All right, the cross-site scripting has it, and you are voted.
Cross-site scripting wins again. Another area where cross-site scripting tends to win is in lists of the most common application security bugs, because it's just so easy to implement. All right. So we talk about injection flaws, and what we'll see with cross-site scripting is cross-site scripting, like, arguably from a super pedantic standpoint, could be argued just to be another type of injection flaw where you're injecting HTML or JavaScript into a web page that someone looks at. But the attack is a little bit different, and again, it's so prevalent that I think it's appropriate to talk about it separately. But here we'll see. If an attacker has control of your browser, it's not really your browser anymore. So what is cross-site scripting? So cross-site scripting occurs when an application takes data from a user and sends it back to a web browser without proper validation or encoding. The victim's browser then renders this HTML and executes JavaScript as chosen by the attacker. Now this isn't a direct attack on the application's infrastructure, right? Like with SQL injection, bad guy is sending something into the application, it's sending that payload to the database server, and so you're attacking through the application server directly at the application's database. In this case, what we're doing is, as an attacker, I'm attacking a different user of the application, and I'm using the application in order to, or as the vehicle for that attack. And the exploitation of this can involve different scenarios, including social engineering. And so that's something that I think, or that I've seen a lot of pushback on with cross-site scripting vulnerabilities is there's typically a couple of steps that have to happen along the way. and I've actually I've gotten into heated discussions with folks where they've, where they've said, like, I don't care about cross-site scripting because that's not attacking our application or our database, that's just attacking other users of our application. Well, I would argue that you should care if people are attacking the users of your application, because if they can impersonate your users, then they can do bad things to the application. You're still going to have to clean up the mess. As I mentioned, this is the most common web application security issue based on MITRE statistics and other folks. And there's a couple different variations. So we'll talk about stored cross-site scripting, reflected cross-site scripting, and DOM-based cross-site scripting. So let's look at an example scenario where an attacker posts a payload to a database or another database store, right? So if I've got a message board that I'm posting to and I'm an attacker, I'm going to post some sort of a message to that, to a post on the message board. But along with that post, I'm going to include HTML tags and potentially JavaScript. So then another user comes along and views my post on the message board, and it pulls my message out along with the HTML and the JavaScript tags that I put in with my message. And the payload gets rendered unencoded into the user's browser. So essentially, I'm able to control the HTML and the JavaScript that's going to be rendered and executed in the user's browser. So again, a good example of this is a message board situation. Again, I'm posting something, someone else views that message, and they view and render the HTML and JavaScript that I included. And that's a horizontal privilege escalation where I'm a user and they're a user, and so I'm able to control that user's browser. But it can also happen it can also cause what we call vertical privilege escalation scenarios, right? And so if I'm submitting a message to, or if I'm able to do this for, say, my last name, and I can get a call center representative to pull up my record and render the HTML or the JavaScript that I put in there, all of a sudden, instead of being a normal user, I'm able to control a call center user's browser. And so again, the scenario here happens in two steps. First, the bad guy is going to post something to this message board, and it's going to have HTML and script tags in it. That's going to get stored in the database. Later on, someone else is going to come along, view that post, or otherwise cause the content that I got stored in the database to be rendered in their browser. Now, all of a sudden, I'm running code and I'm running JavaScript in their browser. And so that's going to give me access to potentially the cookies they have. I can potentially make XML HTTP requests from there. I can log their keystrokes. There's all kinds of really nasty stuff that you can do if you can control some of the HTML and the JavaScript running in a user's browser. And especially now, if you think of with Ajax applications, with these single-page web applications, where there's you have so much code that's running in the browser, so much data that's running in the browser. If I can include code that's running in that browser, that gives me a lot of capabilities in that application. We can also talk about reflected cross-site scripting. So that's a situation where I would, as an attacker, craft a link that has a payload. I'm going to make that available for victims somewhere to click. The victim's going to encounter this malicious link and click. The web applicant is going to reflect this payload back to the victim's browser where it's rendered and executed. So if you think of like a login page, right, where you're going to pass in a parameter for the username and a parameter for the password. From a usability standpoint, right, it might be nice. I mean, hopefully people know their usernames, people's passwords are potentially more complex, right? And so if somebody's going to mess something up, maybe they're going to mess up the password. So from a usability standpoint, it might be nice if someone tried to log in and typed in their whole username, dan@denvergroup.com or whatever. It might be nice from a usability standpoint for me to render that login page with that username already filled in, so the user just had to re-enter their password, right? So from a user experience standpoint, that'd be nice. All right? The challenge is, if I craft a link that says login.jsp user equals dan@denvergroup.com, then the page is going to behave the way you want it to, right? If I have the wrong password, that page is going to render. However you make the HTML inside of the text form for the username, it's going to render Dan Cornell. The problem comes if I render, or if I pass in a username of double quote left bracket and then a bunch of HTML. Again, if the application doesn't properly escape what I passed in, then what I passed in via that link, or what I caused to be passed in when the user clicked on that link, is going to be HTML that ends up getting rendered in that browser. So if you think about it, here, if I find a site that is vulnerable to cross-site scripting, meaning if I craft a link, where you're passing in a parameter and that parameter is getting reflected without proper encoding, I can put that link, craft that link, put it in a spam email, send it out to a whole bunch of folks. Some people are potentially going to click on that link. When they click on that link, it's going to go to server.com, page, P equals, if script equals whatever. When the server renders that page, the script that I passed in is going to be rendered in the user's browser and is going to run in that user's browser. The same thing I can do, again, if I'm posting links somewhere on the internet, message boards, other places where people might click. All right. So the two scenarios that we're looking at here, one is where it's stored, where I as a user get to store in a database some sort of HTML that then gets rendered out to another user. This is one where it's reflected, where I find a site that's willing to reflect a parameter that gets passed in from a link back into the HTML stream, and I cause someone to click on that. Link. Any questions about those two scenarios? Again, this can be a little more viewed as a little more complicated from an exploit standpoint, because unlike SQL injection, where I'm a bad guy, I'm sitting at my standing desk. Because ergonomics are important when you're a bad guy. Find a SQL injection flaw, and I'm attacking directly at the application, potentially pulling data out, messing with data. In this case, I have to find a vulnerability. Oh, hey, here's a message board that's going to render my, what I pass in is going to render it back out. Or here's a way that I can craft a link where I pass a parameter. When someone clicks on that link to pass a parameter, it comes back out. Great. Step two is now I need to get somebody to view that message post, or I need to get somebody to click on that link, right? So there's a break between identifying the vulnerability, and the exploit is essentially two-stage. DOM-based cross-site scripting is a little bit different, where, again, an attacker is going to make a malicious link containing the payload. They're going to make that available for victims to click on. And in this case, we're going to rely on client-side code to misparse the data to make a decision, right? And so if I have, if I've got JavaScript in my application, and it's going to look at things like document.url and make a decision, right? So maybe you've got some JavaScript that is going to do some logging, or is going to look to say what URL now, and potentially this JavaScript is going to execute differently based on that. If the JavaScript is using any of these constructs, URL encoded, location, refer, window.location, these are all values in JavaScript that are potentially partially under the control of the bad guy, right? So, and especially when you look at putting like hash marks for anchor tags and things like that, those don't even go through the server, right? And so if I'm parsing document.url and looking for certain properties of this in order to make a decision, it's important to understand that a user can control portions of that document.url or that document.url encoding. And so if they're making decisions based on that, or if that feeds into logic where they're potentially branching down different paths, then an attacker can control those. So the impact here is moderate. It's not typically immediately as bad as, like, if somebody's running code on your database, that's really, really bad, because all your really valuable data is probably in the database. And so just from a raw impact standpoint out of the gate, cross-site scripting, there's a little more nuance to it. It's a little harder to exploit. The impact of that exploit is potentially going to be different. But there's still a lot of really nasty stuff that attackers can do. They can execute scripts, hijack the user session, deface a website, insert hostile content, redirect users, hijack the user's browser using malware, all these different things. So you've got to really consider the value of the affected system and all the data that it processes. And again, if you look at modern web applications, there's a whole lot of data, there's a whole lot of logic that now exists out on the client side that previously might have been only on the server side. And so that makes the impact potentially really, really severe. Okay, so how do we mitigate this? You positively validate inputs, and I'll talk in more detail in just a second to go into more detail about this. And again, this is something that helps by cleaning up data, right? If you don't, if you have a message board and you don't want people to be able to put in bold tags, italic tags, or if you don't want them to be able to put any stuff like this in, right, you shouldn't allow characters that you don't want to see. If you just want to see alphanumeric periods and spaces and commas, like you can filter it down and say that's all I want to see. The problem is just validating inputs. The rules you're going to be allowed to use to validate inputs are not necessarily going to allow you to filter out everything that you might not want to see in there. All right, what about my math message board? Well, I need to be able to use the lower or the less than, the greater than, and so on and so forth. And so again, input validation helps, and we'll go into a lot more detail in just a second about this. But input validation doesn't fix the problem. What fixes the problem is when you encode the application outputs as appropriate. So if you're rendering something that is supposed to be HTML, right, and you want to render the less than symbol on the page, what do you actually need to put in the HTML string? Ampersand LT semicolon, right? Because what that tells the browser is show the less than character. If you just render the less than character out to the HTML string, what does that tell the browser? Actually, it's telling it, I'm about to start a new HTML tag, right? And so again, if you think of what we looked at when we talked about the SQL injection scenario, right? Hey, I'm passing this SQL query over to the SQL interpreter. It's going to work its way through, right? Like Pac-Man starts at the beginning, you know, chomp, 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 select star from, right? Okay, we're going to do a select query. We're going to take all the columns. Right? The parser in the browser is doing the same thing. It starts at the beginning of the HTML stream and, you know, chomp chomp to like left bracket, great, chomp chomp chomp, HTML, okay, I'm going to render an HTML document. Greater than, okay, cool. Well, that means that I've finished the HTML tag. You know, chomp chomp chomp, you know, less than head. Okay, well now I'm looking at the header of the page, right? So if you think it's just the parser just starting at the beginning and working its way through that really long string with all that HTML data. What we don't want to do is allow the attacker to control the important parts of that HTML stream, right? Which they, you know, the obvious way to do that is with your less than, with your greater than, because that's saying here's the beginning of the tag, here's the end of the tag. And they can say things like here's the beginning of a JavaScript tag, now here's the beginning of some JavaScript that I'm going to run. So what you actually need to do to fix cross-site scripting vulnerabilities is contextual encoding. So that if you're rendering something provided by the user into an HTML stream, you need to encode that so that's treated as data to display, not HTML tags to interpret and to take and to make decisions based on. So now let's do a little bit of a deep dive into input validation. And again, this is a topic that we touched on with SQL injection. We'll touch on it in other parts. But input validation is a tremendously important, just as a blanket thing to do, is probably the best thing you can do for your application security. And it doesn't fix any vulnerabilities. It's not the solution to any vulnerabilities, but from a hygiene standpoint, that's going to limit the impact of any vulnerabilities that are in your application in a lot of cases. So it's a really, really good practice to get into. So you never want to trust anything that is crossed a trust boundary. Josh was talking about before, parameters that are passed in, cookies that are passed in. These are all under the control of the user of the application, and so you have to assume that they're malicious. So anything coming in get parameters, coming in post parameters, coming in HTTP headers, especially cookies, referrer headers, things like that. Anything in an HTTP request is completely under the control of an attacker. And so what input validation lets us do is it lets us say what is and is not acceptable, right? And so if we want to validate input and say we've got a first name, and first names should only be alphanumeric characters, and they should be less than 20 characters long, right? So if we look, Joe, less than 20 characters, that's valid. Only has A to Z09 in there, great. Like Joe, we can consider to be a valid name or a valid username. Bracket script, the length is under 20, so that's good. But it has characters in it that are A to Z, uppercase, lowercase, or 0 to 9. And so this input validation is going to wash through these inputs, and it's going to say Joe is an acceptable username, bracket script is not. All right? And so in that way, you see how we're mitigating or making it harder to exploit potential cross-site scripting vulnerabilities. So let's talk about different approaches to validation. So negative or blacklist validation is one where you go in and you say, I'm gonna reject the known bad. And what this means is you've got to keep a list of what you think is bad. So some of the things that we found, one thing that's bad, right? Apostrophe or 1 equals 1, right? Like we haven't seen a lot of good things come out of allowing apostrophe or 1 equals 1. And so that would be a sensible thing to put on a blacklist. The problem is apostrophe or 1 equals 1 is pretty much the same thing as apostrophe or 2 equals 2, right? Or 3 equals 3, or 4 equals 4. And so you see maintaining a blacklist is challenging because you need to, this list of known bad things is potentially pretty much infinite, right? And it's something you've got to maintain. Positive or whitelist validation is a stronger approach because it says, let's accept the known good. And so let's check and make sure that this value coming in has the characteristics that we want to see in an input that is coming into this application. Right? And so we can say we want this to be strongly typed, right? Should this be an integer? Okay, well that's something we can figure out. Is this an integer or not? Should this be a float? Should it be a positive number? Right? Those are all things that you can track down to. Also you can look for types. Like, is this one of the? Is this supposed to be a state code? Okay, well we can limit that to a list of known good state codes. The length is also something that we can constrain, right? And that can be really powerful, right? How long should a first name be? Obviously, you have to take cultural concerns into consideration and whatnot, but you probably don't need a 2048 character first name. You can probably constrain that down, and so that's going to limit the types of payloads that you can include. Range checks. If there's a number, something's supposed to be positive, something's supposed to be negative. Is it supposed to be a value between 1 and 10? Right, those are the types of checks you can go in and look for. Or are there other rules about this input that we know that we can use to shrink the window of what is acceptable to pass in? Also, is this field required or not? How long should it be? What character should be in there? Are there regular expression patterns that an input, that a valid input would follow? All right. And so if we look at how these different input validation strategies would work, right? In a negative validation strategy, right, we've got the circle there. That blue circle is like all the stuff that you can pass in for a parameter, right? And especially like length unconstrained, that's an infinite set of inputs that you can pass in. You're limited only by like the bandwidth on the internet and like how long your server can stay up to stream the data, right? And so if you go in and say, I want to block bracket script and I want to block on click, you've taken a small set of the available inputs that can be passed in and you've said we're not going to allow these, right? That's more brittle than a situation where you say, I have of all the stuff that's coming in, I only want things that are shorter than 20 characters, and I only want things that consist of alphanumeric characters, right? So in that case, you're saying of the wide world, all the scary things that bad guys can potentially pass in, ones that I've thought of and ones that I haven't, let's only look for a small subset of that. So to the degree that you can do this positive input validation, that's going to provide you with a more robust strategy because you're shrinking the world down very small and saying we only want to let in stuff that we know is good, as opposed to saying, I've made a list of the things that are bad, which is probably not comprehensive. This is what we at least know we're going to block. From an output encoding standpoint, these are the characters in HTML that you would encode. It's typically better to use your, all the major web frameworks have encoding functions. If we look at validating input with Java, again, Java provides regular expression validation, and most of the web frameworks also now have some sort of validation framework that lets you say, here is a regex that we want to see. Here are the acceptable inputs that we would like to accept for these different fields that might be passed into the application. From an output encoding standpoint, again, this is something you can typically rely on your web framework for. and again, it's going to vary, depending on if you're Java or .NET or if you're using Spring. All the major frameworks have these, and they should be easy for you to Google. The important thing that you want to again note is anytime you're taking untrusted data, and that data that's passed in by the user, get parameters, post parameters, cookies. If you're ever going to render that out to an HTML string, make sure to encode that as HTML. Similarly, if you're pulling data from the database, where that data in the database may have come from an untrusted source, right? Then you probably also want to render that. Like a good practice to adopt is anything that comes from a database, anything that comes from a user, anything that comes from anywhere, unless you explicitly expect that it should have, that it's acceptable for it to have HTML characters or JavaScript in it, you want to encode before that goes up to the HTML string. And again, that's a very rare situation where somebody should be passing you HTML that you just want to pick up on the whole and pass over with all of its HTML without it needing to be encoded. So how do we test applications for cross-site scripting flaws? Again, a lot of cross-site scripting flaws have pretty good request and response patterns. For reflected cross-site scripting, if I know what parameters can be passed in, I can put HTML in those parameters, watch and see how the page gets rendered, and determine, hey, I passed in, bracket script bracket. Then I get back ampersand LT semicolon script, ampersand GT semicolon script. Okay, well that means the application's doing what it's supposed to do. But if I get back that bracket script bracket in the place where I passed it in, right, or some other identifier, okay, hey, this application's not properly encoding HTML, and it's vulnerable to reflected cross-site scripting here. It's a little trickier to test for stored cross-site scripting. Again, what you see a lot of the scanners do is they'll put HTML tags with some sort of a signature, an identifier or something like that, a number, so that as you crawl the site, if you crawl the site, submit all these tags, potentially they get stored in the database. Then you crawl back over the site to look and see if things get rendered. If you see that you've got one of the tags that you put in comes back out with those identifiers, right, and it hasn't been properly encoded, then you can identify, oh, on this page, I passed in this data. On this page, I saw that same data, and it wasn't properly encoded. So from a dynamic testing standpoint, you can test for cross-site scripting. This is also a situation where the static analysis tools are pretty good at identifying these situations as well. Where when they're doing code analysis, they can say, I can see parameters that get passed in. So in like a Java environment, if you're making calls to like .NET parameter or something like that, .NET environment, if you've got web controls and the .text. So you can see where those source functions, where that tainted data comes into the application. And you can also look, track the taint as it goes through the application to look for situations where that data, that tainted data, gets written back out to the HTML string without being surrounded by some sort of an encoding function. And so the testing for these types of technical vulnerabilities is usually, the scanners, again, different web frameworks have an impact on this up and down, making things easier or harder. But the scanners, there are pretty good patterns both from a dynamic standpoint as well as from a static standpoint to identify these types of vulnerabilities. So we look at crafting payloads for cross-site scripting. You've got the most basic stuff. So if you've got if you've got HTML that just gets echoed back directly into the HTML stream, bracket script alert, hi, semicolon script, right? That's kind of the most basic test payload for cross-site scripting. And what should the behavior, like if you can inject that in the page, what should the behavior of the browser be? It's just going to pop up an alert window that says hi, right? And so, so that's what, again, that's kind of the most common pen testing thing. And when we talk to pen testers about how they report their data, they're like, yeah, can we include screenshots because I want a screenshot of like my hi banner popped up on this page, to show, yes, look, we were able to inject this script into the page, and I can make the browser do something obvious that is visual that people understand and respond to. As an actual attacker trying to do something truly malicious, that's not a super useful payload because it doesn't do anything malicious. It just warns the user that something weird happened, which is not what you want to do, right? So actual payloads would do things like look at cookies, run other JavaScript, make a web request in the background and all that. But if you think about other situations, you might not get controls as an attacker. You might not get control of the HTML stream in OpenHTML, where you can just start with the script tag. You might have a situation like this where your server-side template says input name equals uname, valuable semicolon, or single quote, and then we're going to echo whatever the uname parameter was in the request, right? In that case, just like we had to do with the SQL injection vulnerability, right? Where we had to say, okay, well, there was a single quote. I need to close out that single quote so we don't freak out the SQL interpreter. Then I need to do what I want to do. Then I need to clean up stuff on the back end so that the SQL interpreter doesn't throw an error, right? In this case, we need to close out that value attribute, single quote bracket, right? So the value is just a blank value. Then we can include our actual payload, whatever it is. In this case, it's script or whatever. And then we need to do something with this single quote slash and greater than over there. And in this case, we can just put like a left or a less than in a single quote. It ends up being a crap HTML tag. And it's not a valid HTML tag, but most browsers are going to like run through that and accept it and just render right past it, right? We can make a more elaborate thing on the back end. So that full payload ends up being single quote, greater than, script alert high, semicolon, and script, and then that less than single quote. So that the render of the page ends up looking like it's supposed to. So from an attacker standpoint, it's important to realize where in the HTML stream do I get control? Is this a situation where I have to clean anything up before I can do what I want to do? And then do I need to do any of my own cleanup so that the browser continues to render and do what it's what it was expected to do? So we talked about testing for stored cross-site scripting. You would seed potentially stored fields in the application with HTML and JavaScript payloads where you have some sort of an identifier in those. So you can identify, like, hey, I put this payload in here, it showed back up over here. Then you re-review the pages in the application to see if those payloads appear. For a reflected cross-site scripting, it's a little bit easier. Send in the HTML or JavaScript payload to the application. Look at the page that renders next and see if anything shows up. Testing for DOM-based cross-site scripting is a little bit trickier. And, the way that we usually do it is looking at the JavaScript that's included in the client side or the client-facing stuff to look for access or look for any JavaScript code that's accessing document.url, URL encoded, location refer, and so on and so forth. And so what we want to do is look for situations where the client-side code is using that, and then probably review that code to see for the JavaScript that is running, that is using these tainted inputs, are they doing anything? Are they making any decisions based on the content that is stored in there? Okay, so to recap, cross-site scripting occurs when an application takes data from a user, in this case a malicious user, and in some circumstances is going to send it back to a web browser without validation or encoding. The major classes that we see are stored cross-site scripting, right? Where at one point in time an attacker seeds something, probably a database, and at a later point in time someone renders a page that's going to pull that content out and view it. The other is reflected cross-site scripting, where we're going to pass something in a request that gets immediately reflected back. So I'm going to have to craft a link that has that appropriate payload and then trick someone into clicking on that link. Or DOM-based cross-site scripting. Again, get someone to click on a link, but where that link is going to have some characteristics that's going to cause parsing that is done on that to make bad decisions. To guard against cross-site scripting, you need to positively validate inputs, right? Again, positive versus negative validation. Wherever possible, positively validate inputs. Doesn't fix the problem, but reduces the exploitability and reduces the harm that can be caused if those vulnerabilities are identified. What actually fixes the vulnerability is escaping user-supplied data that is being sent back to the browser. So contextually escaping it to say, hey, this is content that I want to appear in HTML, or this is content that I want to put into an HTML attribute. Therefore, I'm going to encode it as HTML, or I'm going to encode it as an HTML attribute. We've got references here. There's a great a series of OWASP projects called the cheat sheet series. It's hard to say, but valuable. And there's a great cross-site scripting. It's almost lunch. Cross-site scripting prevention cheat sheet, which is super handy. There's again like a general cross-site scripting articles from OWASP. The SAPI project, again, like these days, I think SAPI has been out of maintenance for a while, but I think the concepts of what they've done are very interesting. And again, for a lot of the encoding functions that they have, like finding the world has caught up to a great degree. And basically all of the major popular web frameworks have HTML encoding, HTML attribute encoding functions, a lot of stuff that for a while were super handy and SAPI. Now, thankfully, those have migrated out to all of the major web frameworks, as well as some other, looking at ASBS for their output encoding, input validation requirements, as well as the code review guide and things like that. So OWASP has a lot of really good materials out there to talk about both detecting cross-site scripting, preventing cross-site scripting, and if you're a tester, finding cross-site scripting. And again, this is a really important area because from data from MITRE, I think it still holds true from Veracode and other folks. The most common web application vulnerability that gets identified is cross-site scripting, and it's so easy. And that's something I probably should have talked a little bit about at the beginning. But if you think about how web applications work, right, where we're going to send some stuff to a server and it's going to send back content that goes to a browser, right? From a security standpoint, browsers have an impossible job. Right, because I'm going to send them stuff, and they need to render that. And the stuff that I send, if you think of like an HTML document, right, it can contain both formatting information, right, with the tags, style sheets and things like that, as well as the content, right, all the words and stuff that I want to show up in different tables and things like that. And with JavaScript, you can also include dynamic behavior, right? So I'm mixing like code and data and layout all in one thing that gets shipped back to a browser, or something where I break it into a whole bunch of pieces and ship it back to a browser, right? Oh, and I also might send you an Adobe PDF document to render, and GIFs and JPEGs and PNG files and all these other things. So from a security standpoint, browsers have a really hard job because they've got to get a lot of really random content generated from different places where you don't have a lot of separation between boundaries between, well, this is code to do stuff and this is data to operate on. All that gets jumbled together, shipped back to the browser, and it has to make sense. And so that's why I think we see so many cross-site scripting vulnerabilities. Is if you look at how web applications actually get assembled, it's a really hard, and I would say even an impossible job that we're asking these browsers to do, because the way that we want to render web pages and all the bells and whistles that we want to have from a behavior standpoint create a situation where it's really hard to enforce that, to enforce those barriers between here is the content that I want you to show, here is how I want you to lay it out on the page, and here is dynamic behavior that I want you to undertake. Right? When all those things get mixed together, you're bound to end up in situations where bad guys can control formatting, control content, and worst of all, control behavior. So it's a really, really hard problem, and that's why, again, I think that we've seen over time, cross-site scripting has stayed at the top of the list of the most common web app vulnerabilities that occur across multiple folks that look for that stuff. Excellent. So at this point, we're just before we break for lunch. Does anybody have any questions about any of the stuff that we've talked about this morning? Yes.
If it eventually uses HTML, am I right to assume that you're saying that the server should HTML encode before you pass the inner HTML function?
So yeah, the questions about inner HTML, yes. Yeah, that's a dangerous thing to.
What if they use the hashtag URL fragment not sent back to the server? Is that litigation?
Right. And so the question is about the hashtags. Yeah, the stuff after the hashtag doesn't get sent to the server, and that is where you're under the greatest risk of the DOM-based, because that's going to appear inside of the page when that page's JavaScript calls the document URL and all that stuff. That's going to appear there, so that's going to impact the whatever processing that JavaScript is doing, but you don't have the chance to weigh in on that on the server. So from a encoding or from an encoding standpoint or something like that. So that means that in addition to your encoding, your input validation encoding having to be correct on the server for any data that goes through to avoid stored cross-site scripting and reflected cross-site scripting, the JavaScript that you write intentionally to be rendered on the user's browser also has to be written correctly, otherwise you run the risk of the DOM-based cross-site scripting. You wouldn't encode it on the client side. You would just need to know from a processing standpoint, you can't make security critical decisions on things in that document, that URL, because that is potentially under the control of an attacker.
So it basically comes down to the properties of the various servers.
Okay, correct. Excellent. Any other questions? Well, fantastic. As Josh said, I think there's a bunch of, I know there are a bunch of places for lunch around here, and I suspect many of them are fantastic. We're meeting back here at 1. Josh, 1 o'clock?
Yeah.
1 o'clock.